Okay. So Nathan. Oh wait, I have always to say. We decided today to implement the types, right? In the parsing. Hello? Is anybody there?
Yeah, I'm
Yes.
here.
Okay. Oh yeah, I'm waiting for confirmation. Because that's a question.
Wait, you want to do what? Type
Yeah, we have
parameter?
two options
Hmm.
to do today. We could do parsing the types, or we can do proper error messages, which we are totally not doing.
Who need their messages, man?
Oh, man.
We literally made half of the parser without their messages. What are you talking about?
No, but it's not for us, man. An error message is for the user when he's writing
Hey,
his
who cares?
code.
Nobody will use this. Who cares, man?
Oh man, Magetta has the wrong mindset, but that's fine. Um,
So let's think. Type parameter. Okay, you're talking about like generics and stuff like
yeah.
that. Right? We don't have that though. But
Wait, can you repeat?
oh, typed parameter. You're not talking about like type parameter.
Oh, I
Oh,
see the confusion there.
yeah.
Yeah.
I understood that also. No. Okay, so what is a typed parameter? It
I
is.
still prefer curly braces, but that's fine.
Oh, okay. So what do you prefer, Nathan? This or this?
Not really opinion about that.
Man, I really prefer parentheses in this case. I'm sorry. Let's
Um,
use the curly braces for ADTs. I'm okay with that. Type
You
left.
want to use all the delimiters we can possibly have.
No, we are not
yes.
using the worst one, which is this.
The angle brackets, not
Yeah.
yet. Just wait
That's not
for
the
the type
worst.
parameters.
What are you talking about?
Okay, so we have that, and then we have identifier. Then we have white space. Actually, I forgot. We also can have white space. Uh, this. Then white space. This. A type, which we will have to discuss later. Right now it's just a string. Then white space star, and then type right delimiter. Is that correct, Nathan?
Wait, I was not paying attention.
We're Mimi on the chat, that's why.
Let me see. Mimi. Okay.
So, what you're talking about?
We want to make the. I want to express in our grammar this thing,
Okay.
and that's the initial approach that I had here in a freestyle. Yeah. And as you also mentioned earlier today, a type is not only an identifier; it is something else. So the type will not be a string. It is a string for now, but I just want to see if the structure of this makes sense.
Well, yeah, that makes sense. But what would be a type?
Yeah.
Oh,
Yeah.
hey man. Oh, it's so fucking much easier to parse the way that you did, Lemus.
Oh yeah.
With the yeah, just take a look at it. Like if they were side by side, you would have to be more careful on where the type finishes and the
Oh,
identifier for
yeah.
the next
Oh
parameter
yeah. That
begins.
yeah. That would be very very not great. Because to make this, man, to make this impossible to be an identifier, that took me a few hours in like 5 a.m. or something like that. Uh, that's fine. Okay, so what is a type? I think that's a good question.
I
What do you
think
mean?
they
What is
can
the plan?
all just be a string because it doesn't make sense to be like to hard code then, right? Because the user can define.
I
Uh,
was thinking
Uh,
about something like this, Mageta.
yeah, just an identifier, that's fine. But that will depend if you're gonna use identifier the same name as
uh,
like a variable, valid identifier, and then a type.
Mageta, we have to consider the features, man. So, for instance, right now we can't declare types. We can't have type variables. So, right now, literally, you could just be keywords, like, and they, let me see, and they
But I think that doesn't change anything.
doesn't. What do you mean? Like
Oh, what
having
would
the
that
features
change?
or not?
Yeah.
Like it does, because for instance, if I'm doing like applications, right,
No,
and
I'm
I
saying
have
I'm
to
arguing that you can't do that. You can, but that's stupid.
wait, what?
Yeah, do
I
what?
was
Sorry.
like making a bunch of keywords. Like, why would you do that in a parser?
No, no. What I mean is using the type integer as a keyword instead of
Yeah,
passing.
but why?
I also don't see a problem with Mageta's approach. Nathan.
Uh, Wait, can you explain me what is the approach?
Yeah,
Maybe I'm
the
not
approach
No,
understanding
the
it.
is
approach is just
considering
parses a string.
exactly. We consider whatever is following this rule. We are not expressing the integer as a special keyword or something like that. It is what it is, and this the Spoon compiler it will handle
Yeah,
eventually.
you just need the primitives, right? Like an integer, like all those things. But you don't even need that. Like you will parse the primitives, right?
Yeah,
Like a boolean, integer,
yeah,
float.
but what I'm saying, at
So
least what I
let me
understood
see.
from your argument is that we don't care with the string itself. It can be anything.
Yeah,
It is a coincidence that the integer is one of the strings that will appear there.
So let me see if I understood. So any kind of identifier of a give format, right? It will be a type, and we will parse that and send to the EST.
Yeah, that's what I understood. Maybe I got it
Yeah,
wrong.
I don't think that works right now. Uh, because, well, we need to have a valid type, right?
No, but I
no,
think
but
that
dude,
in the
the types
future,
are already embedded in the primitives. That's what I'm saying. We're not gonna parse. We
No,
don't have user
uh,
defined parse types,
no,
so it
okay.
doesn't make
Right
sense to think
now,
of.
we don't. Oh, okay, you could do that, and I think it would be a great idea, maybe. But only if you had type aliases, because then you could have like anything and just start a type alias in the environment with the primitive of the integer type, and then okay. And if you have something that the parses and it's not in the environment or initial environment, and if he didn't declare, then it's a type error. But we don't have that.
oh, we do.
Hmm?
Yeah, because Spoon.
Type declarations
No,
slash
no,
alias?
we don't have that. What I'm saying is that if the user is trying to use a type that doesn't exist in a prelude, or it does it in the future will not exist in the user-defined ones, the Spoon compiler will
Folks,
say,
I think we are having a confusion here. You cannot add those types in the prelude.
Yeah, I know, but I don't. I think Lemons also know that.
yeah, I also
So if it's not defined there, what are the specific types? And if it's not on the holy,
prelude.
prelude, how do we know what are the types that we have, the
We are pattern
primitives?
matching that, man, in the
They're
native
the
functions.
primitives.
Yeah, we are
No,
pattern matching those.
We
here,
are
let me
pattern
review
matching.
everything that I was talking about. The only types we care, what are the cases? User defined types and the primitives. The primitives is integer, float, boolean, whatever, right?
Yeah,
We already know how to parse the primitives. We have to do that anyway to parse values, literals,
yeah.
right? So what is the thing that we can do with that? We just parse an integer. Like sorry, we parse an integer and then we yield a string representing integer. So the identifier for the type is still a string, like that doesn't change.
Yeah,
Or an
no,
atom,
yeah,
since
it is an
people do
atom in
that.
our case. It is an atom.
Yeah. Uh, in the case, I think a string will be easier because you can generate, and that's the second part. And a user defined type later, if we're gonna do it, we can just uh, you can basically just do a like a table, whatever, and then when you parse like a type, then you have the type in the table that you can reference, or you don't even need the table actually. But I'm just thinking that's why I'm saying it's better just to do as a random string because on the parser you don't care. You just know that that identifier represents a type.
Yeah, but the thing I want to point out to you, Nathan, is the
Um,
following. This will parse just fine, right? But in the middle of the Spoon compiler, it will try to better match the atom that will be generated by this, which in this case in Erlang would be this. It will try
no, no,
this,
folks.
and it would not work.
Yeah, I think that shouldn't. How can I say that? It shouldn't get out. Yeah, it shouldn't get out of the parser, man. Because see, if
Ooh.
we don't have types that are declared, doesn't make sense for you to accept a arbitrary one.
That's why I
It's not
mentioned the
valid
table in the parser,
syntax.
but I don't think that's necessary now.
Like if
In
you
the
are saying
long
like
future,
let's
Nathan's right, I guess.
no, that's the thing. I think that's the case right now. If we are planning to add type declarations, then you can pass anything. And because, well, it could be a valid time at type checking. But what I mean is, uh, of course, if you do that as a string, and then you are just checking if it's one of your keywords, and if it's not, you fail the parsing before sending it anywhere. I think it's okay. Like that's what I'm talking about.
I don't see that as a thing for the parser to care about.
Yeah, I also think the parser shouldn't care.
Really?
Parser is just like separating things in
Yeah,
tokens
but
and just mounting the ST. If the ST doesn't make sense, that's the type checking and the evaluation.
Yeah,
yeah, but
that's a different thing.
before that, Nathan mentioned something that I want actually to us to establish because I think we're gonna uh, potentially have a future problem. So I want to, before talking all about that, I want to define with you guys what is the scope of the non plus silverware. Because for instance, declaration of functions in the middle, like normal functions, like defun, whatever. Do we want this to be in this version of the language, or we want this to be exclusive to the plus version? Because I already talked to Margita about an object system.
No, thank you.
This will definitely be plus. Uh, type inference.
Oh no.
I also think this is a plus exclusive. And I don't know if we want to have function declarations in a non-plus version.
Oh, here it's just like you make a lambda and do a bind. Oh, we don't have bind.
Yeah, we have only an expression. We assume that the file contains an expression,
Yeah.
and that's it.
Well, we do have binds like using application and abstraction.
Yeah, a closure that
I
represents
was
it, I
thinking that
guess.
these should have the application, abstraction, types, but primitive only, uh, and all the other, I don't know, literal, variable, what I'm missing, oh, condition, and condition. I think that because we know that every going further, it's gonna get really hard because of the language, the base language. I think that maybe stopping at the type, primitive type level is enough, and
Yeah.
then everything that goes beyond that, it's plus version.
Yeah, let's please kill this and then we go for the good language
So, but I want to establish that line, like that frontier, because we
frontier.
are getting pretty close to
Frontier.
getting
Siberia
outside of
frontier.
this. Because we already made all of these. And all of these are just we're not compiling per se. We're just evaluating, but we are very close to. Aside from cogeneration, we are pretty okay. And then today we will be. I want to focus. I want to discuss this first.
Okay, so why don't we just do the normal grug primitive types? Just integer, float, boolean. I don't think we have floats.
No, we're gonna have rationals. That's it.
Okay. And why don't we stop there and then we do all the rest in like a good language because we can like I think we can do faster
Yeah, we can
until
definitely do faster.
we
I can
did,
definitely do faster.
and safer.
And say.
There's also that. And we can plan ahead because I think everybody has an idea on what to do already. Like how because well, we did it all together. So
Yeah, no, I have an idea. I can totally, after having the parser combinators with you, Mageta, and the compiler part with Nathan, I totally am comfortable doing it again. In a good language this time.
we can even use a library to do that. Like for example, we don't need to do parser combinators again. We can just use fparsec if it's
Yeah,
F sharp.
yeah, we don't have to make the basic units. We can just make our own in this case. So we can have a little bit of time, a faster development. So I want to listen to Nathan because he's the one
Regarding the
behind.
line,
Yes.
well, for me it's fine.
Okay, so primitive types is gonna be the ceiling of normal Silverware. Is that fine?
Man. Silverware Plus Enhanced Edition.
Okay, so if the primitive type is gonna be, do you agree with that, Mageta?
Yeah. To
Okay,
me,
so
that's
primitive types will be the ceiling of this version, Erlang version. So we can pretty much discard any considerations that we may have that involve these three and beyond.
we
Okay?
had a wish list, didn't we?
Yeah, but that wish list is totally not realistic.
Yeah. Oh, that's cool.
So, uh, to make the primitive types, then I think that Mageta's way of just assuming this is a string will work just fine. Do you agree, Nathan?
Uh, I disagree
Why?
for sure. Because see, if you are accepting a arbitrary name, because it could either be a type variable or a type alias. In this case, is a type alias. Then in the type checker, you would have a
Oh,
mapping
wait. A
somewhere.
type. Wait. Make the distinction. What you are calling a type variable and a type alias?
Yeah.
Okay, so a type variable is when you are introducing a
Mhm.
type, like a in parametric polymorphism, right? So it is abstract type
Which
and
we
a
don't have.
type which you don't have,
And we will
or
not have here.
okay,
Good, let's just
We
leave it
will
this way.
have this type though.
okay, of
So,
course
Yeah,
we could
yes, it's just that's a primitive, right? It's just a function.
we could do
no, because when I added primitive, you can think only about integers, booleans, and
no,
rationals.
Lemos,
No,
we
no,
would
no.
not be able to do our language without the arrow.
Yeah,
Uh,
and we already have an arrow, I think.
Yeah, that's the thing. We would not be able to compile shit because we are using functions.
no, I don't think you guys are understanding what I'm saying. What I'm saying is
Yeah,
that we're gonna
having
have
the arrow as a type.
no, yeah, but we're gonna have this. My plan, at least when I wrote the grammar there, was to be able to do something like this.
Yeah.
Yeah, we need that. Without that, we can't do shit.
No, you can. We just don't have a high order functions.
Well,
Yeah,
no, no,
well,
no. You don't have any function.
No, 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 no. Oh, now I got what you mean. Yeah, we do have a
yeah.
function type in the Spoon compiler, but that is not the same thing as having this guy
All
in
you
the
need to
Uh,
do is
language
enter the
itself in
functions.
Silverware.
not sure what you mean. For me, it's literally the same thing. If you cannot spit a arrow type from the parser, then well,
You
you
don't have high
don't
order
have it.
functions.
No, no, you don't have functions at
You don't
all.
have the idea of a function.
No, no, no. But again, I think I'm miscommunicating this case. I know that we have a function in the compiler level. We made that an atom, a function atom.
Okay,
But
you're talking about the type, right? The type function.
I'm talking
Okay.
about, okay. Let's not include the arrow in the silverware thingy.
Oh, I see what you mean. Yeah, yeah, you're right. Ah, yeah, yeah.
Yeah,
I
nice.
didn't get it then.
Okay, I can explain again. Or you can explain that then, to see, maybe changing the words and the way of
Okay,
explaining.
so see, Mageta, if I do the lambda
Mhm.
receiving integer, integer, and a body, the type at compile time will have an arrow,
Yeah.
but you are not seeing the arrow anywhere in
Oh,
the
okay, I
parser.
see. Yeah, yeah.
Yeah, so that's why in the grammar I added uh, this. So it is possible to have higher order functions, right?
Yeah.
Yeah. So this is a primitive type asterisk because arrow is not usually considered to be a primitive, but I really want them to be here.
I don't know. I would consider that a primitive.
For us, functional fanboys, yes, but that's not like the status quo, I guess.
I don't know, but um,
Anyway, go on. Why we cannot interpret this as a string
so
and go
yeah.
forward?
Okay, so you guys got the type variable versus type alias, right?
Yeah, didn't finish the type alias.
Oh, okay. So the type alias. In the type alias, I will just accept like any random string because I know that at the type checking type, I will run through a bunch of expressions, and one of the expressions will be a type alias expression, well, or declaration, right? We call it type declaration in other languages because they are doing like the same syntax for declaring an alias and declaring like a new type, like a sum. So let's call it type declaration. And then he's declaring this alias. And okay, when you type check that, that's added in the context. And when you find a function that is using the type in the parameters, because we don't have inference, then he will check is this like if this is a name, and in some languages you can like distinguish already if the thing is like either an integer or any other, and if it's any other, then it's
I
a
lost
like a
already.
okay. So if you are accepting anything at compile time, you will pick that and get the value from the context. We don't have that.
If
Okay,
you're picking
okay.
anything,
I will try
that,
to I will try to tackle this in a different way so then it's easier to Magita and me to understand. Okay.
oh, okay, I see what you mean. But just a second, like you are assuming that we will add to the environment any garbage that you added there, which is not the case.
Let me
Yeah, we don't have function
Like
no.
I
declarations.
understand what you're
Let's
saying. Like you're understanding. Okay, so if you allow the user to add any garbage, it's just gonna keep adding in the context, right? So stuff
no
that it
no no
doesn't
no.
exist.
The adding, I'm not saying about the type declaration. The adding, I'm saying about using any identifier there as type.
Yeah, that's what I'm saying.
So yeah, you have to check somewhere, right? If you are doing that
Yeah,
only
but
at
we're not
type
doing
check.
that.
Yeah, I'm not understanding the
Yeah,
necessity
that's
of
my
checking,
point.
but I'm not understanding the necessity of checking
Okay,
stuff.
let's suppose I add a type called XYZ,
You
right?
can't.
You can't.
That's literally what we were discussing about the city.
That's a parser error.
Uh,
That's
Well,
the difference for me. Like our language has, suppose it has integers and booleans, right? And I add a type there that is XYZ. My whole
yeah.
point is that that should be a failure in the parser.
Yeah, so we need something somewhere to store
no, but
stuff.
dude, I here's my point. Like, I think you can parse that. I just think that when you try to do that on the type checking, it will try to find something like that in the context, which doesn't exist because
Yeah.
you don't have type declaration.
Yeah.
Wait, what the fuck? I'm so confused right now.
Like,
Uh,
if you try to find XYZ in the
mhm.
context of our type checker, it will not find anything.
Yeah, it will throw an error.
Okay.
So what is the problem? That's a type checking error.
No, yeah, but Nathan wants the error to be thrown at parsing time.
No, I
Because
understood that, but I don't know why.
I also don't
that's
know
the
why.
why. Since we don't have type declarations, we cannot have arbitrary types. Like our
I don't.
types,
That's
it's
the thing.
literally a
That's the
set
sentence
of.
I don't get. Why you
Hmm.
can't?
It's not that you
I
can't.
understand. I understand the other way. Like,
Okay, so it's not that you can't. I'm saying you shouldn't. Why is that? Because your types, as we said, we just listed here. They are not arbitrary. They are like a specific defined set. So why is the syntax more broad than that? Like we are not doing metaprogramming. We are
so you
not
just
doing type
so the argument
declarations.
is we just want to restrain the set. That's it.
Not quite, because since it's a specified set that the syntax can accommodate, that should be an
Oh,
error
good.
in the
Yes, but
syntax.
that's not but I understand that, and I think that's a valid argument. But my point is, that's not an argument to overrun the idea of making a generic.
What is the RD of making a generic? I
Like,
don't understand.
here's the thing. I don't think you should parse stuff like that in the parser. You can. In this case, we just have like 5 predefined things. But what is the
Hmm.
point on you cannot define user-defined types? Like, I think of the broad scene. Like, why you want to remove? Like, think it as if we had like type declarations. Let's say that.
Okay.
Why would that also be in the parser? Is that what you're saying?
No, not at all.
So
What he's
what
saying,
would be the approach then?
what he's, what
If we had
he's,
type declarations,
Yes,
then we
it
could
should be in type
accept,
checking.
of course. But
So that's my point.
that's not.
Nathan, can you repeat again? Why do you think that
Yeah.
this error of not
Okay.
having the type needs to be thrown at parsing time and not at type checking time?
Because you can declare and just have like 3.
You can
Hmm?
declare. You cannot
No,
declare
no, you
anything.
can't. It's because you can't.
Yeah. You can declare and you just have 3 of them. So you just like when you parse an integer, you already just add the type integer.
Yeah. Like if you have a syntax that is like not limited, right? Oh, okay. A good
Oh,
example, it's a variable. We don't have a set of defined names that can be variables, right?
yeah.
If we
Well,
had
well,
that,
actually we have now, but
no, we don't. Like suppose
sup
it's infinite.
yeah, no, no, but yeah, no. Suppose it's infinite, but in Silverware we have infinite minus lambda and minus this, whatever is starting with e.
So yeah, like it's infinite, right? You couldn't represent with a some type, for instance.
Yeah.
So okay, if we had like if our variables could be described in a sum type, they were finite, then any variable name that is not one of those would already be discarded in the parser as a parser error. But since it could be an infinite possibilities of what a variable name can be, then we allow anything, and we validate that at type checking.
Wait,
But that's not the
wait,
case with
wait, wait.
types.
I want to go back just a little bit. You said the following. At least I understood that. If you have a a
Finite.
finite set of possible options for types, this should be a parsing error. This statement is my question. The question is why.
Because you can. That's just you can, and it's better. Why it's better? Because well, the sooner the thing, the better. The only case that you would need something more larger, more loose in your parser, that you would expect more to well, in a
I
later phase to
Tell me
discard that
finish.
is because either you need it in the case of you can declare a type, or because it would be good for something like metaprogramming. Because then with metaprogramming, you could do something crazy, like allow random
I
names in the types,
I
and the
just
metaprogramming could be
I
something.
just disagree with that because on that way you're basically thinking, okay, so let's make something that is concerning to the typing of the language in the parser instead of
No,
doing the typing.
yeah, that's not the case. It's exactly the
It's
case.
talking about this, Magetta. The fact that we have two options here, the parser
No, I
already knows
understand that.
this. In our way that of arguing with Nathan, I think we need to say that the literal is this.
Yes, that's what I'm saying.
Okay, so what is the point of we defining a grammar? Why do we define a grammar?
Wait,
Like,
that wasn't the thing, Lemus. Like that shouldn't be a string, right?
What?
Like it should be an integer and a boolean, but I'm talking about the labels for them.
No, yeah, but in the way that
but
we
hey,
go, Nathan.
so we are like defining a grammar because we want to define like what is a valid syntax, right? So we only allow like we are parsing the thing to only allow things that are valid syntax. A syntax That from that we can generate the things that we want, right?
That is a valid syntax. It's just not valid typing.
No, okay, but that's the thing. We want to be restrict unless we have a reason not to, and we don't have that reason here. Because why you would allow like arbitrary things in our parser unless you had the reason that we don't have?
I understand it's like pointless. I'm just saying. I understand it's pointless to do like what WTF whatever as a type. Like that's not a type. I understand that point, but but I still think that's not something you should do on the parser. It's not
No,
a parsing step.
wait. Let me. I think I got the Nathan's argument. I'm gonna
Like
try
his
to
argument
rephrase.
is, let me try to rephrase to see if I understood. The argument is you just have two options because that's your grammar.
Yeah.
So why would you allow something there that is not only those two options?
Uh, yeah, because the parser is using this as a set of rules, right? And the rules are explicitly saying that or you are a number, or you are T or an F, or you're done. But we are allowing that, and the reason why we are allowing that, now that I got it, Nathan's idea, I can say this for sure. We are being pragmatic here, Magita, you and me. Nathan is being
Pragmatic,
correct,
dude.
but we are being pragmatic.
Depends on what you mean by pragmatic, because both are like easy as hell. Now, maybe cutting on the parsing is even easier because it's literally checking.
I mean,
Is
whatever.
that
Let's just do anything, man. Let's just do anything.
Okay.
Just do Nathan, what Nathan is asking. Just do.
Okay, so we're gonna not allow this to not be one of
Yeah,
the.
whatever. Just do an
Yeah, but
integer. We can
this
do that on the integer
this will
function.
fundamentally change
It
the
will be the
parser.
same thing, I
No,
guess.
we need something to store now.
Oh, we already have that
We
on
do?
the ST. Yeah.
No, in the ST. What are you talking about?
Go to the. Oh, you don't have the other project open.
Yeah.
Let me see here.
Yeah,
I
but
don't remember how we're
this will
doing
fundamentally
that.
change because none of the parsers are like trying to find something inside a set, you know.
no, no,
Aside from the
wait.
white
We have
spaces.
alternatives, man. Like it's what we need, right? So a type. So a type is alternative, right? You agree with that?
The type is the first one. Yeah, the type is like a literal whatever, and then it accompanies the thing in the first. So that's how it should be.
Mm,
Wait. Oh, that's an abstraction.
we're gonna have to, when parsing the parameters of the abstraction, we're gonna have to do some like lookups in something. We
Lookup?
we can use the alternative approach, but I think that's kind of cheating
No,
because we
we
have
only
only
have
two
two
options.
choices,
We
right?
have
So
three.
just do the alternative with the
No,
two
no,
choices.
wait. We need alternatives like anyhow in the same way that we define expressions. Because, well, they are
Oh no, we
composable.
don't.
And
Oh no, we don't. We
we
can just use this
don't.
lookup. That would work just fine.
Okay, how will you do with the arrow then?
Just do a parser type, man. Whatever.
A parser type.
Yeah, a
Yeah,
type, and then you just have two choices, which is integer and boolean. That's it.
not quite. That's like the terminal ones. But
Yes.
you also would have the arrow and composing.
Yeah, we have four options: rational that we don't have implemented in the compiler yet, but integer, boolean, and arrow.
Let me.
Therefore, infinite options.
The arrow produces the exponential growth in this thing.
And there is a thing. Can you show me how do you want to do the parsing of the arrow? Because
Sure,
then
it's
it's
like
left a
this.
recursion.
It's I did like very loosely like this. Now, actually, this is like this. Wait, I cannot put the arrow in the same. Yeah, okay. I think that's the way that I would do it again. Yeah.
Yeah, so there are two things. The first one is how do you want to express your arrows? Because you see the approach that you took, like A, arrow B, arrow C. We usually use that to things that are like carry by default, right? Because they are one argument. We could do that also for our language, even though it has arity and such. But in other languages, people do like, wait, they do like a tuple or something like that. Because, well, arity, right? And the other thing is you are not considering things like parentheses that you would need to specify the, how do you say it? The precedence? I forgot the name.
I thought I did it in this way because of Haskell. Basically, Haskell ignores the parentheses 99% of the cases. So
Yeah, that's a total bullshit because, uh, like, I did an example for you, but let me do another here in the chat. But this that I'm typing is different from
the only case
the.
that I saw that makes a difference is the one with the higher kernel types that you talked about.
So
For
take a look on
our
that.
language, I don't really see the. Yeah, in Haskell is the same thing.
So yeah, that's not a very specific case, man. That's literally any case in
Yeah,
which the
no,
arrow is to the left.
yeah, but that's what I'm saying. In Haskell, it will ignore the parentheses altogether.
No, 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 that's a lie.
No, that's not.
Wait, wait. Am I doing this right? Yeah, yeah. Do you know why? Because see, in the first one, you can partially apply A and then B, right?
Yeah.
You can't do that with the later. You can only pass one thing, and that thing is a function.
After the session, I will show you with GHCI.
Man, like, I would really like to see you because you see in the first, you can pass two parameters. How do you pass two parameters in the second example, then?
How do you pass two
And then
parameters?
he says there's no tuples in Haskell. And then you go, oh no.
No,
No,
if
that's
you
not a tuple.
yeah,
That's a
that's not a
function.
tuple. That is a function.
Wait,
Look at the
what are you
chat.
talking about, man?
Look at the
Oh,
chat.
the chat.
Yeah, look at the chat.
A, B, C. That's like A curries, B curries, C.
Yeah.
Okay. Then A, B, tuple, C.
Yeah, that's not a tuple. That's the second A comma B is a tuple. That's what I'm saying.
Yes, that's what I'm saying.
Yeah, no,
I'm
no, but
talking about the third line.
he's talking about the third line though.
A, B, C, those are, well, they're the same thing.
Yeah,
Huh?
it is lambda
What?
calculus
No,
thing,
no,
right?
wait. Let me delete the other message just for be completely sure. You guys are saying that those two types are the same thing?
Yes, they are.
Sorry, guys,
What is
you
the
are
difference?
confusing with something else. You are confusing with this here. Those are the same thing.
I can again in GHCI. Maybe I'm wrong, but I'm 99%
Okay,
confident.
what is the difference then? I don't see the
Okay,
difference.
okay. The difference is, uh, let's
Oh, okay.
suppose,
It just
yeah.
takes a function, but I'm confused because
Okay. Okay, so we do need parentheses then. And how are we gonna do that?
Unless you do something crazy.
Uh, okay.
Take a look at this. Let me send two examples, man. Oh, that's just cursed. But it is an option if you are brave enough or crazy enough. People will say different things about you.
Is
oh,
it
that's
what
awesome.
Baguette wanted?
Yeah, that's awesome.
This is exactly what
That's
Baguette wanted.
easier to parse. It doesn't have left recursion. You don't have problems with
Yeah,
precedence.
there's no space for ambiguity.
Yeah, yeah, that's true.
Yeah, but how? Oh, to
It's hard
compare.
as fuck to read though.
Yeah, it's very
Nah,
unreadable.
very
Very
ambiguous.
unreadable.
What are you talking about?
So yeah, it's very unreadable. I'm not
Imagine
showing this on the screen. Let me
just
put this on the
imagine,
screen.
just imagine.
There is
This.
no way you would be able to read that faster, Magid.
No man, it's like reading sheet music. Like you
Huh?
get it.
Okay, maybe eventually you will be used to, yeah.
That's beautiful. Look at that.
Man, I can't tell what that is doing.
But
I
Nathan,
can't.
Nathan, we need to. I think we need to hold Magetta on this one. What do you think?
What do you mean by hold my guitar?
Because if we allow to go in Magetta's way,
No,
it's
no,
gonna be like
hold my
this.
guitar. It's like
Like not allowing Magetta's intentions to go
oh
further.
yeah,
I
yeah,
get
yeah. I think we
you.
should hold my.
Because this is very
Yeah,
unreadable.
it's unreadable, man. I can't. What the fuck? Yeah, I can't figure out looking at it for sure.
Yeah, this is so unnatural, you know.
Dude,
Um,
that's what I don't see what you guys are talking about.
Nah, you're just memeing.
No, I'm not. Like listen,
Memeing,
like what
100%
is that?
confirmed.
Okay, so right on the right, what do you think that is?
Wait, can you repeat?
Like you're picking something that will send an integer. Well, change the types because they're all like the same thing. But like A, B, C.
Wait, what is the plus there, man?
no, it is because Magetta's point is that this is
Yeah.
consistent with this.
Yeah.
Well, yes, but
In this case, it's not a good one, right? But yeah,
yeah, this case is ultra simple, right?
yeah.
Yeah, no, when you
But,
get go crazy, right?
but change like the int to ABC there on the last one. ABC. Yeah. What is that?
Okay, so that
A
is a
function
thing
that
that returns a.
a
Okay,
C.
go on.
No,
The
no, go
return
Nathan.
is C.
Go Nathan.
Okay, so it is a function that receives a function that inner
No.
function receives A and returns B, and the outer
Okay, we
function
don't have recurring.
returns C.
Okay, that's fine. Yeah, it takes an A to B and then it delivers a C.
Yeah,
Okay,
but
that's easy.
no, like if you go to your first example, that is just a bit bigger, it's already a lot harder to read.
Oh, okay. Pick the string lemons. Oh, not the one, man. That one's Mimi.
Only the first one is already hard enough, man.
Look at that. Like you pick two things, a function.
Like especially if you go to the
You
things on the
know, no, but
left, it's harder, a
what?
lot
No, it's
harder.
I need to say something that will make Magetta smile, which is that I don't think it's actually that harder to read. I think that
No fucking
because
way.
of the convention that reading from left to right that the Western culture has, then it's hard because here I'm already getting used to read because here you
You
have to
really
read
start.
from the middle.
Yes, that's what I'm saying. Like you always start in the middle. There's no mistake.
Yeah,
Like
you
Folks,
always
that's the
start
whole
in the
point
middle.
we're using pipes and shit.
Yeah, I
Stop
agree.
using pipes then.
Yeah, stop using F sharp then. Get wrecked. Uh, I but be honest, now that I already read like 3 times, I'm already okay. This is a function that starts from here. Whatever this is,
yeah, it's
No,
a function. It's a function that takes another function from strings to string. It delivers a string. Then
yeah.
it
no.
delivers.
My point is not that you not understand at all. My point is that
It's hard.
holy fuck, man! For you
Yeah.
to understand that, you need to pay attention, to stop at it and read. Like in the other ones, well, we look at
Let's do
and we
like
know it. Like
how it would be with F sharp. It would be something like async. Let me do something here.
Man,
That
it,
would
well,
be
it
that is
will
also
be
the
beautiful.
point that we are
Western reading
used
style.
to that, right?
Yeah,
That is also
we are used to left to right. Yeah.
no. I'm not thinking even about that. Something more specific. We are used to reading like Haskell and F sharp type syntax, right? That is that. But yeah, what you said is the most important. We are used to read left to right, and doesn't please don't come with an argument of oh, but Arabic and like other people in the world and shit because man, nah.
You need to stop reading manga, Nathan, because then you are complaining. Oh, left to right. Okay, so stop reading mangas then.
I read it in English, and the pages are right to left, not the words.
No, not the words, but the pages, right? which is very
Yeah,
unnatural for me.
that's totally not the same thing, man.
No, it is the same principle. It is the
No,
same
no,
principle. It is
That's
not
starting
at
from.
all.
It is the same principle. What are you
No, do
talking
you
about?
know why? Because it's not your eye movement; it's your hand movement. That's totally different
No, my
for
head. No,
readability.
I don't know what you're talking about. But okay, let's go with this one.
that's
Wait,
awesome, man.
this one, this one, this
Why,
one.
like, are you worried?
What? A lot, a lot.
Oh man, this is gonna be beautiful.
Holy shit!
You
Wait,
can totally tell.
I need to abstract out these guys because they are confusing me. Wait, because now we have these and these as the arrow part. Wait,
Huh?
wait.
Oh, we need the return as well from the function, right? We're not handling
Okay,
that.
so it's a function
No, it
that
can just be the
grabs.
last one, right?
It could be the oh, we're handling as the body, right? The return is the body,
Okay, so what we are doing here.
like this.
Wait, the return is the body?
Yeah, on the way we're type checking, the return of the function abstraction is the type of
Wait,
the
is
body,
this
right?
correct?
No, that's not precise when you are receiving a high order function, my
I'm so
You
confused.
need to have the return type in the arrow.
Guys,
Hmm?
Hmm?
this function here, it is taking this, right?
Hmm.
And it's
Yeah.
doing. This is the first thing that
Yeah,
it's
this is
receiving.
one function.
Yeah, but it is receiving
3 parameters.
three.
Yeah, the
No.
last one it's supposed to be the
Oh yeah, the
return.
last one is the yeah.
This is the return.
Yeah.
Yeah.
Yeah, so what is this float just chilling in here?
It's
Well,
the
this
third
is the
parameter.
third
This
one.
is the third parameter.
Yeah. Like the first is a sync unit, the second is a function from string to
Wait,
integer, the
why
third
did
is
you
a float.
understood all the complex times and not the float, man?
Because this is
What is wrong?
this is breaking what these others were doing.
Ah.
These ones were always binary.
No,
And
no,
No,
Magenta
no,
just
but
transformed in
yeah,
mult parameters because we don't have curving, right?
yeah.
So
uh,
it's a list of types. It
oh,
has
it's
at
a
least two.
list.
Of
Yeah.
course.
Ah, okay.
It's like A, B, C, then the
Yeah,
return.
it needs to have at least two, and the last one is the body. Well, the return type. I mean.
Okay, so the we have a tuple of three things as parameter, and the return is this guy.
Yeah, yeah.
Yeah, I really would prefer following this philosophy if we're gonna do this.
What about
Hey,
following a
dude, what the
normal
heck?
one
That's
from
so
not
easy.
crazy people?
No, that's not easy. You're gonna lose me if you continue with this argument. I'm gonna tell you
Dude,
right now.
what? No, man. Like you understood something convoluted, like the one in the. Like
Are
I
you?
agree, that's convoluted.
No, but this is so
And
much easier for me than this one.
what?
I totally agree with
No,
Magenta in
what?
this case, man.
For me, this is so much easier to read.
Dude, I don't know what goes
You
into
are
that.
crazy, Lamb.
What?
The first one is a lot easier, man.
No, there's no way.
And by
It,
the way, like both are valid.
yeah, but they do represent different things.
Yes, they are different. So you're not comparing the same thing.
No, they are different, but this is actually what something that is bothering me is that these three guys they are like combined, and there's
But
no
dude, they
those.
are as well in the second, in the third. Like they're the same thing. It just happens that the parameters that I'm sending is just one.
Yeah, but there's no notation that I can see that these guys are glued together. There isn't
Are
even a
clue to.
parenthesis,
Oh, you
Man,
want
but
more
that's
for
the
instance?
same.
We can
which is
have it.
already better.
No, but that's now.
That's the same thing. Oh wait, not the
Yeah,
same thing.
not
Yeah, not the
really.
same thing. Yeah, you would need like commas or something like
Yeah, we
that.
need commas or wait.
Oh
Well,
What?
no,
we're
no,
using
That's not
that's
even
spaces.
list.
cursing the syntax, man.
We,
Don't do that.
oh,
Yeah, don't do
cursing. You
that.
mean that you want to be here, the comma?
Oh fuck.
Oh, that'll be
But
awesome.
Lemus does have a point with the all the parameters have been a list. Like
Now
that's
this
what
is
list
better.
does.
Now this is better.
No, that's man.
It is
I
consistent and it's
Add
following the
a,
same philosophy.
oh
I
yeah,
can't
I
look at
get it.
all those things. I'm just like
Yeah,
switching
the
tabs.
comma is a function, right? And
Yeah.
we're applying.
It's
It
because
is.
of
Yeah,
Haskell.
it is because of Haskell. In Haskell, you do like you can
He's
do all
also a
this.
type constructor, right? Not only a.
Yeah, yeah.
Oh shit, that's really bad.
Uh,
Oh no, wait, it's not.
No, you
It's
can.
not a type constructor in Haskell.
Uh, well, maybe we're
You
gonna have a problem with the names again. But this, as far as I can tell, in Haskell, it is a type constructor. This.
okay? What I mean is, in the same way as arrow is a type constructor.
No,
Folks,
it's not
let's
the
just
same.
do the thing and then we
It's not
can
the same.
change later. Like, we're discussing too much already.
Yeah, we are 1 hour of discussion. Okay, but we need to decide this because
Okay,
uh,
let me like say my part first. Like ultimately, I don't really care. We can do all the cursed stuff.
That's pragmatic. I like that.
I just want to point it out that the point that was raised regarding we can change it later, it's much harder between those choices. It's not that simple of a thing.
yeah, I agree with Nathan. I think that we need to decide it. At least the structure, like if it's gonna be like this or not.
Crazy or not, right? That's
Crazy or not, what the heck, man?
the bias. The bias.
Oh no. Uh, well, what is the decision then, Nathan? Because Mageta's
No, no,
thing.
I said my point. That's with you guys now.
No, man.
Do whatever, man. Just do Rob Pike. Like,
Okay, I said
first
that
Rob
doesn't
Pike.
matter. Magetta said that doesn't matter. That's your vote now, Lemos.
Yeah.
Okay, okay. I will make it a deal
Just
with
one
Mageta.
thing, you will be the responsible one for everything that happens.
No, I'll not be the responsible. You guys voted with don't care. So, if I vote with don't care, we get stuck. So I need to. Someone
Yeah,
needs to care, right? Yeah. So I will make a deal with Mageta. Okay.
A deal.
Yeah.
you.
A deal.
If you agree that in Silverware Plus we're gonna do it in a normal way, I will allow in Silverware to have in this way.
Dude, I don't care about Silverware, man. This language, we're not gonna even be using this after we do Silverware Plus.
People said the same thing about PHP. Look at it now.
Oh no. Oh, I got a point.
Okay, so deal.
But you have a problem with PHP, Nathan? Are you
Of
saying
course
anything?
not.
Focus,
No,
Mageta.
it's a great
Focus.
language.
Wait.
Focus. So do
Oh,
you agree?
okay. Or what?
We're
Or
gonna
what?
we're gonna do the normal way of using the arrows in Silverware
Dude, just
Plus.
do what is easiest. We don't have curry, man, so who cares?
Wait. What is the point about curring?
Like, I think the first notation, like this notation, would make more sense if we have curry.
The first
but Nathan
notation.
said that this way is easier, man.
No, yeah, it is easier. But
Yeah, first, yes.
can you show like the way that Magetta did with multiple parameters?
Yeah.
Just put an example with the other int. Okay. So see, the two first ones for me they are like giving the meaning of currying Magetta. The last
Yeah,
one, it's
yeah.
not.
Yes, I agree.
Anyway, if Mageta accepts this deal, I'm okay with doing
This
the crazy
deal.
way.
Let's do.
Deal
Yeah,
with the dev.
do
Are
it
you
like,
taking it, Magetta?
yeah, do it binary, man. I think,
Wait, what do you mean by binary?
yeah, like just two, because we don't have anything. Because it doesn't make sense to think of. Let me see.
But binary is like
No, never mind, never mind. Yeah, never mind. I'm just thinking of bullshit.
just one thing, and it doesn't change much the difficulty
Yeah, I don't
regarding
think so.
being two or a list.
Yeah, okay, so I will understand this as an okay. So Silverware Plus will not have this.
Okay, but is it two or is it a list, Lemos?
Uh, parsing wise is
It's the same thing.
no, it's not.
Okay, it's almost the same thing.
We would have to make a parser for the list one.
We are doing lists everywhere, man.
No, we are doing
That's
only for
not a
the
problem.
alternative, the list.
Ah?
Yeah, the parser. We
No,
don't have a
no,
parser
no.
for parsing like a bunch of things in a
No,
like
no,
a
no, no.
very.
We are doing that already. Parameters are that, for instance.
But I think parameters we are doing.
Hmm?
Let me check. Oh, it's the many, right?
No, wait. Oh, you're talking about parsers, right? Not the grammar.
Yeah,
Okay.
I'm talking about the parsers.
Yeah, well, if you did in parameters, then we already have a way to parse
Okay,
lists.
so let's use list then. Okay, so uh, guide me, Nathan. Yeah. What is a
but
type
that's
then?
the but that's the same thing as we did with like expressions, man. Like literally the same, but with types. Like we don't have more tricky stuff that we did than with expressions. In the sense that okay, let's like talking like grammar wise. It will be alternative, right? Like
It
the
will be
type, the
alternative.
parser type is alternative, and the first options that we have are the literals, right?
Yeah,
And on that, you can ignore the white spaces, right?
yeah.
Because the
And then
uh
now that we have a type, this is also like arrow, I guess.
yeah, like it's basically like delimiter, white spaces, arrow, and then a list of types. Like just as you just
Okay, so type left delimiter, white space. Oh, the identifier is the name, like X. And then
wait, wait.
oh, and then here is where we change. It's
What
a
what do you
list.
mean? What do you mean by identifier?
Yeah, because we're gonna have the X and then a space and then the type.
Oh, okay, that's typed parameter, not only the type, right?
Yeah, the type
Why
is only
don't?
literal and arrow here.
Wait, can you show me again your syntax?
Uh, no, here.
Yeah, yeah. So on the typed parameter. Oh, okay, okay. Can you show me where you are defining the parameters in the grammar?
Can you show me where to find the parameters in the grammar? The parameters are here.
The parameters are there. So why don't we do the following? Like we do the grammar for a type, and then you fit the type in the parameters, right?
No, because oh, we're gonna replace this one. Okay.
Yeah, because right, we need to
Yeah, we don't
add
have type
type there
infos. Yeah. Yeah. Sorry.
somewhere, right? And then let's start by defining like the grammar for a type.
The grammar for type. Yeah. So this is the what we have.
Yeah. So it's either a literal, right? And
Yeah.
that could be abstract. They are just base types.
Yeah.
Or it's something else. There's something else has the delimiter, white spaces, arrow, a list of types,
So it
and
would be white spaces plus.
wait, you are closing, you are opening a group there, right?
Yeah.
But what you need is actually the delimiter, like type left delimiter.
No, no, no. But I would. Uh, I
No,
was
no, but
thinking
that's part of a type. Like that's not part of a typed
that is
parameter.
part
That's
of a type.
yeah,
I'm
like
confused. As far
let
as I can
me
tell, the integer doesn't need delimiters.
type on the chat. That's a type, and it has
Oh, for the
parentheses.
arrow one.
Yeah.
Oh, okay. Okay, so it's gonna be a left,
You
a
don't need
type
a group
left.
there though.
How are you gonna compose stuff?
No, no. Yeah, the group starts after some things, not there before the
Oh, okay.
delimiter.
Okay, so delimiter, then white spaces.
That's so funny. Like you said that you really like that meta syntax, and you are literally basically doing what people already do.
I don't get the point, but okay. Go.
Okay, so we do have that. Then we have the arrow for
Arrow,
sure,
and then a
and
bunch of white
then
spaces.
a bunch of stuff. Like let's define it by last, and then you have white spaces, and then the closing delimiter, right?
Where is the opening? Because you said it's not here.
Yeah, it will be somewhere after the arrow, right? But let's jump to the end because it's easier. On the end, you just put like white spaces, like star, and the closing delimiter, right?
Okay.
Now, yeah, the group is not there that you close.
Yeah, okay, go on.
Yeah, you are not using the type right delimiter after the white
Oh,
space.
okay.
Right.
Here.
So, okay, so now we need to handle the least case in the middle, right?
Yeah, you mean this.
Yeah, like that's the thing. We don't know yet if wait, yeah, we don't know yet if it begins like there in the type, there in the white space. Like, how do you want to do that?
It needs to be at least two, right? There's something
At least two?
Yeah, because you have an arrow.
At least one, right?
At least one. And
Yeah, because like see what I
can you have this?
oh, at least two you mean the least. Oh,
Yeah.
yeah. You need at least two.
Okay, so it's gonna be white space there, and then some sort of a type. More
Oh
white spaces.
fuck, that's interesting.
Yeah, I'm actually having flashbacks with the list thing that we did last time around. Do you remember
The
that?
non-empty one,
Yeah,
right?
the non-empty
Because
one.
you had at least one, yeah. So your cursor is there. So arrow, white space plus, then you have type. The white space is a plus there after the first type, right? So yeah, and now you have a problem there, don't you? White space. Yeah, I think we'll have problems there. Yeah, because see, you have the white space plus, right?
You mean this
So
one?
no, the last one.
The last one.
Yeah, you will
Okay.
have problems with that. Because see, if we don't have the other types, we only have two, then that's not a problem, right?
Yeah,
Oh, that's
that's.
yeah, no, that's a problem actually, because you have type, at least one white space, and then the delimiter closing.
Oh,
That's
that's
already a
yeah. That
problem.
is a very similar problem to the we had this last time around.
Oh yeah.
Uh,
But well, that sure will be easier than parameters because we don't have like a e-commercial or some shit like that.
wait, no, we're not gonna drop the e-commercial man.
No, I mean on the types list, we don't have a special case as an e-commercial as we did in the list of parameters. That's what I mean.
But wouldn't that mean that typing the language would drop the
No, no,
variadic?
no, no. What I'm saying is, uh, oh, that is a
We can't drop this.
no. We are talking about different things. What I'm saying is the grammar that you are defining for a type includes a list, right? We defining a list. I'm saying that that list is easier than the kind of list we did in parameters because we don't need to handle a special case on the end. I'm not saying something regarding dropping or not the commercial. I'm just saying it's easier to define the grammar for types than for parameters.
Okay, so what's the problem with the current one?
You mean the types?
Yeah, the type definition in the grammar.
Yeah. So let's see. Arrow, at least one white space. Type, at least one white space. Type. If we don't have the optional stuff, then we have zero or yeah, zero or more, and then the delimiter. But if we have something, we need then at least one and then time. There you can have zero. I think that's correct.
Yeah, but we need to add this guy back now.
Yeah, now we need to put time. That's
Ooh.
yeah, that's our problem.
Ooh.
Yeah, but I think it's not that hard. The only thing is, you know the group that you are using for identifier? That
Uh,
part you will only add delimiters inside the group and add a type somewhere.
Wait. You're talking in here, right? Somewhere in here.
Yeah, you have a group, right?
Yeah, here.
Oh,
The
back.
first group
Mm-hmm.
that you are using for identifiers.
Yeah.
There, you will put delimiters inside the group, and then you do something like, obligatory space here and the type, and that's done. Fire, type.
Are you still thinking, Lemos? Just do it, man.
Yeah, now you just put basically the same white many on the beginning of the group, and then you put one
Wait, the
delimiter
beginning
in.
of the group? You mean here?
Yeah, because you put a delimiter before that.
Oh, a left type.
No, that's the left delimiter there, isn't it?
No,
Or
the left
wait,
is the bracket. You want parentheses for this guy, I guess.
oh, can you show me the syntax again? Oh yeah, you are right. It's parentheses.
The only reason why the parser went so in one day, Maget, is because Nathan convinced me to do this.
To do what?
Uh, um, a grammar file.
Oh,
Just a second, because I'm talking through Amazon service.
Okay.
so random.
No,
Oh
wait.
man, I bought a thing and the thing like arrived was different, so I'm just like giving it back,
Oh,
sending it back.
Okay.
All right.
White space. Identifier, white space plus, type, white space this. What do you think, Nathan? Oh, we
wait.
also need a right at the
I'm
right
not. I'm
place.
not looking at it right
Oh,
now.
here.
Okay, I'm done. So what is the thing?
Right delimiter. Okay, I'm pretty confident this is right.
Let's see. So type left parameter white space arrow white space plus. So it needs to at least have one space.
Wait, what is the line? Can you go to the line
Wait,
that?
wait.
Like,
Does it need to have one space at least? I don't think so.
Let me grab this because it's so much easier with an example. Holy crap.
I don't
no,
think we need one space at least on the arrow.
can you go to the line that? Yeah, you don't need a space up there, but if you want to,
Maybe
you can.
space star instead of plus.
Oh, you mean this one?
Yeah, on the types it do, but on the arrow, I don't think it do.
Oh, wait. Yeah, you don't need.
Oh, you guys want to allow this to happen?
What's the problem, man?
I
That's
mean,
beautiful.
I hate this, man.
You're spending 1 byte less. Not even 1 byte. There's just that's just
Yeah,
space.
that's a decision. So, what was the line that you were reading, Mageta?
These are the
The
lines that matter.
line. Yeah, I'm reading the type.
Oh,
White space plus. Then you have what is the brackets like the
Grouping.
squared brackets grouping? So it's like two possible like two of them is a sequence, right?
Yeah.
So as many spaces as you want, following of other types.
Yeah, if you have an error, you need to
not
Okay,
have.
and
as
the
you
type
want,
could be
as
an
many
arrow.
as you
Okay,
want.
that
It
makes
needs to
sense.
be at least once.
No, wait. No, we need
What?
to. From...
The plus, like
Yeah.
on the
Oh,
Yeah,
you
the
grouping.
need.
white
Yeah.
space
Okay.
needs to be at least one. Yeah.
Yeah.
White space, blah, blah, type right, blah, blah, whatever. And then
Okay.
you have
Okay, but this is
like,
the type. This is being used now. Okay, you read this, Magita. Reading the
yeah,
type. Now you to read this one. It
yes,
is
and
this.
then,
Right.
Yeah.
Yeah.
Type left delimiter.
that looks fine.
One space.
Yeah, that looks fine.
Wait, I think we have a problem there.
Where?
Where?
Yeah, these. Oh no, sorry, I was seeing the wrong thing.
You're
And
thinking too
this,
much.
and now that you know that, and now that you know how to read the
Wait,
X, to read both of them,
almost
you go
one.
parameters.
Mm-hmm.
I think this is right, Nata.
Uh, no, that's wrong. You remove the space there somewhere
Where?
The
on
space
the typed parameter inside the grouping.
In
You need a space there somewhere. You
inside
see,
the
you are
group.
repeating. Okay, you don't need to, but you should add the possibility of having. You see the typed parameter that is inside the grouping and it is repeating
where is the grouping type parameter? We don't have grouping.
parameters.
Oh, okay, here.
Typed parameters inside the grouping.
Oh,
You
we
need a
need at least
space
one.
there.
Oh, the white space, yeah.
Uh, yeah,
We don't
but
need the
wasn't
white
that
space,
the
don't we?
That was the problem before. Because how am I going to differentiate between this one and this one?
yeah, but you are doing some way. Can't you do a Control Z?
Oh man, because
Save
Emacs
the
is
file.
garbage in this.
Save the file.
Because Emacs is garbage in this sense. I
No, no,
need to.
wait. Copy the whole file
What do you
first.
mean Max is garbage in this
It
sense,
is.
man? You
I
have a
have.
tree. You have literally a binary tree to handle
I.
your Control
Yeah, but I
Z.
need to. I need to keep pressing Control XU, and I can't hold the
Dude,
Control
just
X. It's so
download
stupid.
Huh?
all the tree queuing. Then you're gonna have like an entire tree.
Yeah, that doesn't sound like a Max problem, man.
No, it is because I need to put more effort in doing Control Z, man.
That's
I
just
hate that.
bullshit. It's bullshit.
But isn't the point the editor of you being
Okay,
able to
here.
change that?
Yeah,
Okay, here.
That's the whole fucking point?
yeah, man. He's complaining about nothing. It's
No, I'm
just
complaining about the stand that the default is garbage. That's what I'm complaining.
Okay, so that's a star. So use the fucking star. You are using a plus.
Yeah, but now how are we gonna separate? Oh, the parentheses. They will separate
go
first.
have dinner. I'll be back.
The parentheses you said.
Yeah, because if you have a bunch of typed parameters, how are you gonna separate them? And the answer is this.
Wait a bit. Parameter.
That's why we added the this man for the same reason to have a token to separate them.
I'm not sure what you're talking about regarding the parentheses because before we didn't have parentheses and that was working.
No, before we didn't have parentheses because we didn't have the concept of a typed thing, which is another group of different things. What I'm saying is,
Sure.
let's suppose that you have a typed parameter, and then
Hmm.
you do not put the white space. How that's gonna look like
Oh
this.
yeah, that would be okay.
Like
Yeah.
this. And I'm just saying that why this star instead of a plus works? Because we have a way to separate them even then they are glued together. Which was not the case at some point in the conversation before because we were talking about we have this
Oh,
identifier
I
and this one.
remember because it was okay with the other one. It's because if it had zero spaces, then it would not happen because they would be considered one.
Yeah, and then you
You
said, "Oh,
know.
this is it's the programmer's fault, not ours fault. Not it's not
Oh,
us."
I
Yeah,
see.
yeah, but I think this is
And
done.
yeah, that's better than allowing like not that allowing, that requiring like at least one in the end of the thing, right? It's better to have the parentheses glued than that. Well,
Oh, there's a
possibly
problem.
glued.
There is a
What is the
problem.
problem?
Uh, we cannot use literals there.
Hmm?
Type atom.
We cannot use litres there. Oh yeah, yeah, that's a lot better too. By the way, Atom is a really good name.
Primitive is also fine.
I wouldn't say quite the same, but maybe they, by coincidence,
By coincidence.
yeah. I'm trying to think about a type that is not an Atom slash terminal
Yeah, but
and
we don't have to think about them because we only have
okay.
4 types, man.
No, no, yeah. So just for the sake of thinking about it, right?
Yeah, but let's continue with atom in this case. Okay, now that we have the
Mhm.
grammar, we can start adding these things. Oh man, I love this part. Discussing is fun, but doing it is even more. Um,
Uh-huh.
yeah, that's I'm saying the truth. Okay, so we're gonna make the typed parameter now. That's what we're gonna do.
Wait, are we starting with typed?
Oh, the type one you want.
Of course, it's the like smaller piece, right?
The type atom is the smaller piece, by the way.
No, yeah, but yeah, composing, right? And
Yeah.
it could be inlined, right? But of course, you would prefer otherwise, and I think it's also
Okay, let's
best.
make the type atom. Okay, so def fun type atom. It should be this. We don't have a parser map for that yet, so it's gonna be a parser header.
Parser map.
And I want.
What do you mean a parser map?
It's because in order to translate between the um,
No, that's bullshit. Don't we need only like parse a string and then do a empty with something?
I don't think you got why we need the
Okay,
maps, but later I can
so
explain.
let me write in the chat.
Yeah. Okay, so what is this? What is the def atom? It is an alternative, right? It is an alternative of two things only. So that's really easy. So it's going to be alternative of. Um, ooh, we need to create an atom. Do you have that
So
parser?
wait.
We have a parser for an atom. Because if you don't, I'm going to make it immediately.
So take a look on my example.
Sure.
By the way, I'm not sure if the bind is what you would use there.
Okay, so what do you want to do with that?
So that's the same as the mapping.
That is the same as the mapping.
Yeah, if you know all the cases.
Uh,
Like, by the way, I will start today with parser combinators in Okama.
wait,
Like doing. Yeah.
wait. Uh, Sum operator, is that a type constructor?
Yeah, it's a value. Like any value.
Yeah, it is the same. It is the same in that case. I prefer the mapping though. You can use a bind if you want. We don't have an atom, man.
What do you mean? Atom?
Yeah, we don't have an
I'm not
atom.
sure what would be the parser atom.
It would be a parser that grabs a string and returns me the like tries to find. It's an extended version of the char.
Standard version
Yeah,
of
so
the
yeah, the
char.
char parser it picks a character, then
So
tries to
it's
find
like a
that.
string but without the quotes. Is that what you mean?
It is a string without the quotes.
You're just matching with a string instead of matching with a char. You cannot say it parse string because it would not have quotes.
Yeah,
So it's a match on a string, right?
yeah, it's a match on a string.
Okay.
Okay, so how is
That's
the
easier,
atom?
isn't it? Isn't just do a match on the beginning of the input?
The beginning of the input.
Yeah,
That is a
like starts
prefix.
with.
That is a prefix. Oh, we have the atom. It's a prefix. Nice. Totally forgot. Okay, so it's prefix integer. Okay. Prefix boolean. And for now, we're gonna keep with that. And that's it. That's the type atom. Done. Next. And I guess the parentheses are breaking now. Oh, it's missing one. Okay. Um, okay. The next, let's do the arrow, which is also a prefix. Arrow. Parser header. Prefix. Done. Arrow done. The typed parameter is basically parameter, but we with the type unit inside. Let's make the type now. This is the big moment. Pay
Mhm.
attention to the big moment. Parser header alternative type atom or whatever is that. Um, okay, I'm gonna change this. Instead of having the in the implementation, I'm gonna do like exactly the same because I don't think it makes a bunch of sense.
Mm. Wait, can you repeat that, please?
Yeah, I'm
I
gonna
think you have the
replay.
last session recorded.
We do. I'm gonna just do this in the implementation. That's it.
By the way, what you did there on the grammar actually also would not usually be the way. Like, why would you like right do a separate one just for?
Oh, I remembered why we did that for delimiters. Is because we can change
Yeah,
the
because we
marks
can
freely.
change. Yes.
Yeah, so I am still following the principle that I said.
Well,
Just change the
yeah,
grammar
just
also.
yeah, just because they pointed out that you are doing the grammar wrong. Well,
Um,
unusual choice.
this is pretty similar to what we usually do. So it's gonna be a just right.
Wait, arrow?
Yeah. So it's gonna be app.
Wait, what?
We're gonna have
No, no, wait, isn't that?
char opening
Oh, okay, arrow type. Oh, okay.
white spaces star. Um, just right again. Prefix
Oh,
arrow.
regarding the Rust parser combinator,
I will
they
use
don't
that.
have. Hmm?
I will use it eventually.
No, yeah, but the thing regarding they don't have a denotation, like in general, they have for like results, maybe for options, like it's the not interrogation, well, question mark, right? I think Cecilia showed you maybe.
Mm-hmm.
Uh, So yeah, they have that for results, and the parsing is using results, right? So it makes a bit nicer to write parsing it. Ah, you still don't have operators though.
Yeah, that sucks. But I'm kind of after this experience, I'm basically like full speed now.
Now, after
Uh,
doing the worst possible, right?
and this is wrong.
No types, no
Yeah, but
operators,
that's
no
something.
denotation.
Yeah, but that's something that I talked to Magit in one session that you left earlier or something like that.
Mhm.
The fact that we don't have all of these more powerful tools, which at the end of the day, although they are really powerful and elegant, they are also conveniences. Um,
Hmm.
I got so much more closer. I'm so much more comfortable with the idea of parser combinators because I have to do everything myself. I don't have the guarantees that the more powerful languages provide me.
No, that sounds like bullshit.
No, I'm
If you
telling
were,
you my experience. I'm not
yeah,
telling you
I'm
about your
telling your
experience.
experience is bullshit. So I'm
So
saying you,
I know much
I'm
more about parser combinators that I now that I debugged without the types, for instance.
oh, without the types.
Yeah,
Okay,
that's what
yeah.
I'm talking about.
Okay. Yeah.
Exhaustiveness, type system,
No, yeah,
everything.
then I agree with you because well, you have to check everything in your head. But yeah.
Yeah, I have to do everything by hand, and I'm much more comfortable with it because I never did. Like I already did a little bit with the functional programming course that I did during university, but that was not like getting your hands dirty. This is for me.
Depends because you don't really have time to study the things you are actually interested in, right? In uni. You
No,
have
you
a lot
do.
of stuff to do.
No,
You
you also have
do.
no you have stuff to do, but you also have time.
I don't know, man. Like because I'm not as efficient as you, like for sure. Like I usually need more time to do stuff.
No, I'm not saying I had like plenty of hours to do nothing. No, I did I had stuff to do. I'm just saying that. Uh,
Okay, what I mean is you had a class on parser combinators, but it is not as if I was doing right now studying parser combinators, and that's the only thing I'm doing in my free time. So you see, that's what I mean by not as much time.
oh, if that's the case, yes. But I didn't, like I said, I didn't had the experience of making everything from scratch and like getting really, really comfortable with the idea. Because I remember in the beginning of Force Combinations, I was kind of uncomfortable with the idea that I don't have data.
You don't have data.
Yeah, at compile time, you never have
Oh,
data.
at comp.
The data comes
Oh,
only
okay. You
when you
mean
do
you are
the.
doing composition, right?
Yeah,
Instead of
I'm
actually
doing.
running.
Exactly. You don't have what people usually call the flow of the data. You have the flow of the composition
Yeah,
itself.
yeah. But what you just said, it's bullshit because at runtime you don't have the data also when you are doing the composition.
No, at runtime I have because I'm calling it. Of course I do.
No. No. Uh,
Of
what I
course I
mean
do. I'm
by
just gonna call parse and put the data here. This is the data.
no. Okay. What I mean is, if you are not doing run parse, like if you are only doing the combinators in parses, you don't have data. It's also just composition. It doesn't change if it's runtime or compile time.
Wait, say it again.
Okay, when you have compositions, like you are not applying the functions on primitive types or types that. Okay,
Yeah,
like
we are.
everything
We
that
are.
you're
We are
saying.
doing exactly what you said, right? This is a
No,
run.
no, no, wait, okay. What we are saying is actually all bullshit because, well, functions are data, right? But ignoring that,
That is very, very bad interpretation.
huh?
Yeah, because functions are data, yeah, but that's not the way that we are using the word data in this context.
No, yeah, like
That's
the actual
just
string, right?
yeah,
So
that's just
okay, so let's talk about this thing. So in that sense, uh, like at runtime, you also don't have data. Why is that?
why.
Because if you are not calling run parse,
Which
you
we
are
are,
only
right? Which you are. So it's already kind of meh, but okay, continue.
man. You are not calling that.
Yeah, this is an
That's
alias for
inside the
run.
function.
No. This is literally run, if I'm not mistaken.
Okay, let me show you some. And I will write in Lisp just because we are we already cursed enough. So let me do my examples.
You are already cursed enough.
So
Ignore that. App.
okay, are we running plus with our data? That's on at runtime. Like we don't even have type check in there.
Yeah,
Am I
no,
running
no,
my input on the plus?
no,
So you also are not running get parser?
no. I am because I am
No,
providing. I
because
am providing something to the abstraction.
I'm also providing something to the plus.
No, but that depends on something else.
Depends on something
Yeah,
else.
the
As
plus.
you are.
No, you are doing from the inner out.
Okay, what I mean is,
You have a plus, but that plus requires an x, which is inside what is
uh,
the lambda is providing. So you're not
man,
applying. You need to apply the thing to the outer one, which is exactly what we're doing here. We have this, which is a bunch
Lemos,
of parsers, and this is the
if
input.
I Lemos, if I evaluate the expression that I just typed, will the plus be triggered?
No, because it depends on the lambda.
Okay, sure. The
Okay.
lambda being applied, right?
Yeah.
If you transform this defun parser in an anonymous function and you evaluate that, will get parser being triggered?
The get parser requires an external out input. It does
No,
not
wait.
work.
Just answer my question that it's easier for us to do the follow-up. If you transform parse in anonymous function and evaluate that in the repo, will get parsed being called at compile at runtime?
So instead of the parse doing a fun call, it is a lambda.
Yeah, because a fun call we cannot just evaluate as expression, right? Well, kinda, but
Yeah,
For
but that's yeah no. I agree with you that if the parse is actually an anonymous function with a lambda, then calling parse in the REPL it will not trigger data at runtime.
wait, depends on what you mean by calling. I didn't say calling. I'm saying
No, you just
evaluating.
evaluating. That's
Because
fine.
calling it's like application,
Yeah,
right?
which is not what we are doing.
Yeah, we are
So
just evaluating the abstraction, right?
yeah, here we are actually doing what I said. At runtime we have the data. If we do in the
No,
way that
no.
you
If you are
said,
just
Andra,
no,
what are you
wait,
cringing about?
wait, just a second, Magita. If you are just defining it, you are also not running get parser.
yeah, of course I'm defining I'm not running, but that's not what I'm talking about.
Okay, but that's what I said. So if you have those things, those functions, even if you are composing them, get parser is never called unless you actually use the run parser.
Yeah, but doesn't make
And
sense.
yeah, my point is that's also at runtime.
No,
Then you don't have data at runtime. And you said
yeah,
you
because
had
yeah,
at
what I
runtime.
mean when I have runtime is that I'm calling parse, and the only way to call parse is providing input to it.
Okay, but see, you were talking that the whole thing was confusing because you didn't have data, right?
Yeah,
You are
because
only doing
usually
the compositions,
yeah, because
but
people
that's
usually
not
say
because of.
follow the flow of the data. That's what people usually say.
Yeah, but see, that was not because you had types and it was at compile time. That's because you are not looking at the point of parts, like see,
Oh,
of the runtime.
oh man,
That was not.
I know why the back quote and the comma work there now, but that's another topic.
I just want to no it's this is a what Mageta what Nathan and I were discussing it is a communication issue again. I think the Nathan is just not understanding what I'm saying again. What I'm
Okay,
saying is that you when you call this function in a REPL or an executable, you call parse. The only way to pick this function and makes it execute something is providing an input.
sure.
Do
Yeah.
you agree that in this particular explanation, this would be the data?
Yeah.
That's what I'm talking about. The only way to have the data inside the composition that we are making here is if you call if you force the parse to runtime.
Okay. So let me ask you something. You said that you were having difficulties because you didn't have the data. What would be an example there in this file that you don't have the data and you would have difficulty in your unit times?
Well, being honest, and that question is good because being honest, after some time, I kind of uh, okay. So you want an example, right? Where is the data here?
Where is the data there?
Yeah,
Oh, okay. See what you mean.
that's what I mean. Is that we
Mm.
don't have a string to print in the middle of the composition.
Oh, okay. But yeah, then that's only for applying the combinators, right?
Yeah, which is the function that part of the functional course was about that.
No, no, but I mean, when you are defining the combinators or when you are defining the parsers, you do have the.
Yeah, you do have the data there because of the anonymous function with the input.
Oh, okay, sorry. Then I misunderstood. You were only talking about I have parsers, I have combinators, and I'm using them to compose.
Yeah,
When okay, I see.
I want to print the data. I want to see the data, but there's no data in
Yeah,
here.
but again, that was not because of types and not because of compile time. Because if you run that, you also
Yeah,
like.
no. If you force the parse to compile time, then the data will be kind of spread out to this. It will be internally. You still don't have explicit access from here.
Yeah, and also those get parsers are not being evaluated, right?
Well, I don't know how LFA does that.
No, 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 no. Come on. If
Come
you
on.
find a language that you are like evaluating, oh, sorry, yes, actually, yeah. Okay, I'm saying shit. Okay, let's add mainstream there. If you, oh man, that's so cool. Like, uh,
You, okay, so let's. But I want to listen to Mageta for a bit because he said he discovered why the back quote in the comma.
Yeah.
I have
Okay.
an hypothesis. Can I tell? Can I say the hypothesis
Yeah.
first?
Go
Okay.
on.
So I think that what's happening is that. Oh, do you know what we were talking about, Nathan? We were talking about this.
like quoting in.
Yeah, why
Okay.
quoting and comma works is because you're quoting this entire thing, and then at some point that I don't know when it's gonna happen, then the comma comes and like forces it. That's my hypothesis. Go. Because at the
Yeah,
beginning I was combining these two, like, oh, this is
yeah,
annulating this. This is dumb.
yes, but and I also think it's that because you're basically the problem we have is basically when it tries to evaluate the parser, right?
Yeah.
To make the composition. So I think that by adding the backquote and right away evaluating the block forces you to um, forces you to evolve the thing completely. Like because you have there are two steps. There's the first backquote, the build parser, and there's the second backquote, which is that one internally.
Yeah.
And I think the quote you add there, they're evaluating two different things at two different times.
Yes, exactly. Yeah. I don't know
In that
how
makes
I
sense.
got this working, but it works, and I'm not changing it. Okay, now app. We're almost
The
done, by
thing,
the way.
Lemus, that I was talking is like, uh, if you have a, well, maybe I'm saying something wrong because I'm not thinking that much about it. But what just came to my mind is that if you have a pure language, then you can rewrite the body of an abstraction like as you are evaluating the abstraction, right? Because, well, you have no side effects. So you are just rewriting the body to be a simpler thing. But
I need
yeah.
another time to talk about that because right now it's complicated.
Man, just a short parenthesis here. I bought a package from Japan. It arrived in the airport and then it was ready for customs. The the delivery company literally removed the date, the estimated delivery date, because they got like it got delayed and they removed. So now, like, just to say, oh no, like we're not delivering like out of the date. Like, we're not late. There's no date.
Wait, that doesn't make sense because don't you have the estimate date on the site that you
No,
bought?
yes, because they got late, they removed it.
On the site?
Yes,
Oh, I thought we were talking
just to
like the
fool me,
package or
man.
something.
Yeah, just to fool me. Like, what the fuck?
I think we're done.
Anyway, so let me see.
Yeah.
Just right, white spaces, just left,
Oh no no
many,
wait. I'm missing a white space. Just right.
just left app, then identifier plus the type with white spaces. Uh, yeah, it needs to at least have one, right? That's
Yeah.
true. And then any white spaces as you want. Then after that, you have optional. Very okay. Yes, variadic. Mm-mm-mm. Yeah, that looks okay. But then you need the parser map now, right?
Yeah, we need to map it to the correct one to spoon.
Yeah. So let's test. Let's see.
Just a sec. I just want to see if this is just left. Okay. This makes sense.
Oh, the thing, Lemus. You see there that you have a comment to represent the code that you have,
Yeah.
right? Like the thing that can get out of sync. If for some reason it happens that you are using a
Oh, our language doesn't have comments. I just noticed that.
oh
Oh yeah.
really? Oh okay, yeah, that's true. But if you are using a language, well, not very as a language, but if you are using like a parser generator, then they don't get out of sync because the description
Yeah,
of your
yeah. The
grammar is the
description
code.
is it is the how the parser generated parser will do I know. Okay, so how to test it? Let me get out of this. Nick shell. Um, rebar 3 LFA REPL.
I'm nightmares because of rebar.
Speaking about that, did you solve it? The
No, I
using
think we're
mix?
gonna have to make a server. That's
Nah,
easy.
no.
Think about it, Nathan. Like
I
we
refuse.
make a
I
server.
refuse.
We make a
Mm.
server for the parser, a server for the compiler, and then you send the code via server.
No, you sure can do that.
Yeah.
I would not guarantee that I will be able to watch that, but
No,
That's
but
okay.
dude, like our compiling our binary will actually be a server. So
No,
imagine how cool that is.
that's okay. Like if it works, I don't need to look at it, right?
Oh man, that's so sad. It's like it's the idea of like uh, using TypeScript, right, to write apps like Electron garbage.
I don't know. It's just the thing of you are like you have to delegate something, right? Because
Mhm.
well, you can't do it yourself. And then the person, oh, are you doing that way? And well, maybe you don't like that, but you cannot do it yourself. Then you just say, it, oh, you do
Yeah.
it. Are you not like? Are you not taking a look on side? I will just use it, right? So you not
That
complain if it's
application
working.
remove one parenthesis.
Where?
Oh, the parenthesis. Oh, yeah, remove. No, that's right. What the heck?
Did you literally copy and paste it?
Yeah.
Yeah, it's understanding as an application.
No, not parse. I'm dumb. It's parameters. Uh,
Wait, what? Wasn't that the thing that was already defined? Like,
Wait a second, Nathan. So lambda x space integer
No, don't
space.
you need to just send the list? The lambda will fail, right?
Wait, then plus this. This. Oh no, you're correct. Maggot, sorry for that. Now it is. Let's see.
No, you don't need to quit.
Ooh. Oh, parse. Look, the best error message possible, right?
Specific char. Okay.
wow, you know what function failure?
Yeah, but
Wait,
uh,
you don't get the stack trace?
no, because I don't. It is failing in one of the parsers, man.
Oh, but wait, is the
But what? What?
remove the squared brackets?
Remove the square brackets.
Yeah.
But hey, aren't you like
No,
launching
there's
an
no. They are
exception?
correct. They are correct. Man,
No, but parameters.
go, Nathan.
Man, you are launching an exception, right?
I
So,
am. No, it's not an exception. It is a tuple.
ah,
Yeah, this is a tuple.
When we get the that's our policy. Whenever you're getting
oh,
an error, you
okay.
should like save the position.
Yeah, that's what I said in the beginning. We had two options: parse types or make proper error messages, and that would include the position.
Nah, but who cares, man? Like we
Who
can totally
cares?
debug that. Let's see. Now go back to the parameters.
Parameters.
So just left app identifier, then just write white spaces at least one type. Okay.
And the
Uh,
type, it is an alternative between an atom, a type atom, and an arrow.
okay. Yeah, I get it.
Oh, I'm dumb. Okay.
Mhm.
Um, this is incorrect. Just
What?
yeah. This is incorrect. This is incorrect. Uh, just right. We are missing parentheses, guys.
Oh, right. That's true.
Uh,
That is absolutely true. But wait, no, that's opening parentheses, right?
yeah.
Yeah. Actually, shouldn't that be? No, but wait, don't shouldn't you do that the in the parameter? Aren't you doing that already?
No, the parameter is opening the list only. Only the
Okay, yeah.
list.
Hmm.
Okay, so you grab this one and then just left
Yeah,
for the
but you still need
alternative.
the identifier inside, right?
No, it is already here, man.
In the type pattern?
Yeah.
No, I'm talking about like X.
The identifier is in the parameter.
Yeah, but it's not inside the parentheses.
Ooh. That's a good point. I need to make it here. I cannot
Yeah,
do it in here.
yeah, it's
Okay,
trash.
so let's remove all of that. Let's.
The levels got really acquainted. That's really impressive, man. You got really acquainted. You know exactly. Is it because of the colors, or you
Yes,
just?
colors. Uh,
Oh, it's impressive anyway.
Thanks, man.
Another one, right?
This,
Yeah.
yeah, and then this guy will be. It will necessitate a just left.
Hmm.
Wait, wait. This is wrong. This is closing that.
It's two twice
This.
back.
Oh, here.
Yeah.
Just. Oh no, app. Uh.
Actually,
Char
they can, right?
and white space.
Oh, right spaces. Yeah.
And we also need to add white spaces to this guy. I forgot.
I would say this is convoluted, but this is really easy to read. No, no, really. Like, I'm not joking. Like, this
Only
is
if you
very
have big brain, man.
no. Like, if you have if if you have the indentation like correctly, it's very easy, man. Like this.
I would say it's the same thing about the types there. Of course, it's not that you will not be able to understand at all, but you will not parse as quickly as, well, something more sane, I guess. But I agree, if you have very big brain, it doesn't matter.
Something is fundamentally wrong. Wait.
He didn't understand the
No,
closing
we are no,
bracket.
we are closing no, we are closing some parentheses wrong. We can see it here.
Oh, it's really
Yeah,
parentheses.
but we need to discover where to
Oh,
put
you
that
need
one.
one in the end,
No,
don't you?
no, no. It's not, I don't think it's removing. It's internal. These extra parentheses should be like removed from there and put it somewhere else. This is the app. This is the just left. This is wrong.
Yeah, you should have the optional sign, right?
Wait, what? Oh no, that
Mm.
makes sense.
Dun, dun, dun,
We could also do
dun,
like this.
dun, 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 dun.
We are ignoring the white spaces in the closing brackets with the just left. And this it needs to include it needs to be inside the app. That's what I need. Is this with the app?
No.
No. This needs to be green as far as I can tell.
Now it
Oh yeah.
is.
Yeah, now we're talking. Okay. And it's too wrong. App and mini.
Let's see everything from the beginning. So just right, and then we have an app. That's right. Just left. Where does it end? It ends down there on the last line. Then we
Wait,
have an
wait, wait,
app,
wait, wait, wait. Continue.
and then we have the applicative that should have the many and the optional. And then we have inside the menu just left with the app.
Yeah, this I
Just
can already tell this is wrong
yeah,
because these parentheses they should.
yeah, yeah. You can remove one from there,
Yeah, definitely one wrong. And
and
then
then you
these will.
close. Is the app with the applicative? Can you go up?
The app with the applicative. No, this is. I think this is the one.
But I'm talking about the inner one.
Inner.
Can you?
This?
No, like go to the app, white spaces, char, closing bracket.
Go,
Sorry, closing parents.
where?
Yes, there. No, go down. 2 lines. No, one above, one above. Go to the end. I think that's mapping. Yes, that's right.
Okay, so it's an this seems right then.
Yeah, this is right.
Oh, okay, this is right now. This is the only thing that doing from the FS expressions that I really hate. Unknown
You mean
form.
the consistency?
No, I mean that the parentheses start to get really annoying when you indent it in the way that we are indenting. Ah,
Interesting.
cool. This is correct. Okay.
Correcto. Instead
Uh,
of doing like strings, do an atom.
this is it. No, this is an atom, man.
No, like look at the result.
What is the problem?
Integer, their strings. Just do an atom. That's better
Oh,
on Erlang. We're gonna
oh,
get
I
this.
would change that when doing the parser map. Uh, uh, yeah.
Try to parse the entire lambda now.
Actually, yeah. Let's try.
Actually,
That there actually the parser bind is better in this case to transform this. But I will do that later. Let's do the correct way now. So expression, and then we have lambda. This is the list of parameters, which is fine. Then you're gonna have here and here. So let's sum them. This should be an abstraction, right?
mm-hmm.
Cool. Magetta. Let's try to break it. Um,
Oh wait, fuck. Yeah, I don't think we. Wait, did you account for that case? We don't have type on the rest.
Yeah, we don't.
the grammar
No,
accounted for that, I think.
no, the grammar didn't.
The grammar did.
Really? I was not paying attention when you did that.
Here, we have a typed parameter,
No,
and
no,
then
no,
we
no,
have
no, no,
this.
no, no, no. Look at the second group. Doesn't have a type.
Oh, you want to type the variadic part now, right?
It's not that I need that I want. We need it.
We need it.
Oh.
Oops.
Wait. What is a typed parameter? Typed parameter. Yeah, we need the delimiters there also, right?
I'm thinking about that.
Oh, okay. Maybe we. No, no. Yeah, we do. We do need there inside the grouping.
Uh,
Because otherwise he will be like, try to write that, like for you to see on your example.
no, that's no. I can already see.
The guy who is part to another.
Yeah, this will be huge because of the delimiters.
Yeah.
Left. No, type.
Yeah, but that's because you're writing the delimiters by hand.
Yeah, if you want to change to curly braces, it's easy. This, then identifier, white space.
Yeah.
No. It's before, like before the.
Yeah, I would say yeah, you can do that as well, but that's
No. I would prefer the variadic trigger being this outside.
Oh, okay. I see.
Why don't you do curly braces then?
Oh, okay. And then you don't allow spaces, right? Oh, okay.
No,
I
but
see.
Magetta said something interesting.
What did you say, Magetta?
Instead of doing like an ampersand and then a delimiter, like a normal one, you just do
Curly braces.
a curly braces. That's
Yeah,
an
that sounds
specific.
that sounds like shit. What is the consistency of that?
What is the consistency of this? The percent outside.
It's just to raise awareness. That's the point.
The E is raising awareness, but you are also using the same delimiters for
No,
consistency.
you're just like bullshitting. Right?
No, not at all.
Look at this.
Nathan, you
That's
don't have a
so
reason to
awesome.
choose this, man.
Huh?
We don't have a reason to specific.
No, we don't. That's just because Lisp does
Yeah,
that.
that's just
No,
a
no, no, no,
Lisp
no. Wait.
inheritance.
What Magetta is saying is that we want to specify the last one as being delimiters with braces. My point is that this is less consistent than what you are
No, no,
doing,
you
Lem.
didn't get his point
It's
then.
less
You didn't get
consistent.
his point then.
Can you
Ins-
write for me then?
yeah, instead of using, it's very easy actually. Just do this. Uh, I will not put the white spaces, but we will have white spaces at the end. There, like this.
So you have double delimiters.
Yeah, but the outer ones is to explicitly
Look
say
at
the
that, man.
variadic part.
Dude, copy that, Lemus. Copy that.
Let me.
That's amazing, man. That
No,
looks
no.
awesome.
Yeah, that's not what you did, Lemus.
Of course, the part
No,
I
no,
didn't
it's
know.
not. No, no, you have double delimiters there. He
Yeah,
doesn't.
we have double delimiters. I'm not saying different.
No, no. See your grammar for variadic. That's not what Magetta wrote.
Oh yeah, they
Oh,
should be
you're
outside.
talking about Discord. Ah,
Yeah, and Magetta, I think that is also easier for you to confuse those ones depending on the font. Like the Discord font is
I
really
don't care
bad
for
for
the font,
reading that.
man. It's the problem of people they using like
it's the problem with
fewer
people.
fonts. It's their problem.
Yeah, of course. Maybe if you are blind and the thing is being like red for you, yeah, then it doesn't matter.
Or we use something like this. Dude, I'm just like brainstorming right now of the beauty that would be. Like, think about this.
Man, you talk about Go, but you do as much as good as of a language design.
Look at this.
You have Go ideas.
Which delimiter do you guys prefer? That, this. Oh,
No,
I
that's
know.
terrible. This last one
I
is
know.
terrible.
The only thing I would say is that if Go had the rest parameters, it would be one of those for sure.
What about the Spanish exclamation mark in the end?
I
Like
don't
this.
even I don't even know
Do
I
you
have
even know
that.
how to type?
I don't have that. I think in my keyboard.
We can do this.
Maybe
Look
he's
at,
using Unicode.
that's perfect.
How does he does that?
No, no, no. That I would be really pissed if I got a language that was using this.
We're
Well, then
literally
you do
locking
not like
language for
Agda
like
and such.
Okay, I
Latino.
will ask Nathan. Nathan, the curly braces. What do you think?
That's bullshit, man. That's totally shit.
And that is just a European. What about the earmuffs?
Do what?
Earmuffs.
Oh. Yeah, but
What about this then?
No, no. Forget. The curly.
using other delimiters, man. Like,
No, no, no. Look at my screen, Nathan. Look at my screen.
mm,
We would be signing the variadic part with the curly braces. That's my proposal.
yeah, but not double delimiter, right?
No,
As you have it right now.
no, right now it would be double delimiters to be consistent with the other ones.
What? That
But you
that's
can
not
only have
consistent.
one.
No, that is consistent. The consistent is you have a parenthesis, an identifier, and a type, and a
Uh,
parenthesis. And you can have multiple
okay,
things like this.
I agree with you. You have some consistency, but it's a
And then
shitty
and
consistency.
then this is to sign that this is the variadic argument at the end.
Yeah, that more nested is just bullshit, man.
No, you don't
I
have
don't.
an argument for this, Nathan. It's just personal preference. You don't have an argument.
Well, no, actually, I do. Like, the more nested something is harder to read. Like, I think you guys
Cares? It's
can
not an
agree with that
argument.
for
It's
sure.
not an argument. Just that people are dumb.
Well, sure. Like, if you have too much of a big brain, then you don't need to worry about that.
Yeah, exactly. Dude, who cares?
Who
It's not like
cares?
you're talking like anybody will code on this, man.
For the sake of simplicity, and because I already did it and it took so much time, I will do the
No, man,
ampersand.
you're giving up.
I already did.
Yeah, I already
You're
did.
giving
So
up. No, man, you're giving up.
Silverware Plus, we can discuss more.
You should go. You should go over Nathan, man. Like,
Go. See the words there? He's not choosing that by accident.
you bet.
Okay, so now we need to parse the. We need to change the variadic part. It is in here.
Yes, sir.
Oh, here. Instead of
By
being
the way, I
optional
forgot.
this,
How do we do the optional?
we do an alternative with empty.
Yeah.
Okay.
Uh, typed variadic, and that will be the other line that I already forgot.
Delete this,
Typed.
please. Delete the space, please. It's killing me.
What is the space?
There's a space before the type of variadic that you just wrote. No, no. Yeah. Thank you.
Oh, yeah, yeah, that's bad.
It was giving me.
It was giving. Uh, okay. So, ooh, I just noticed something. We are not gonna create this one. We're gonna change the variadic one because this is very, very internal to the variadic parser. And that kind of sucks, but that's fine. Variadic here. So this is the how it's gonna look like. This is the optional part, which is not here.
Wait, the evaluation is not accounting for types, right? And ignoring them. He just
No,
doesn't
yeah.
have it, right?
Yeah, it doesn't.
Oh, okay. Yeah, then you can type check, but not both at the same time yet, right?
Hmm.
Uh, this
We should add some functions in our prelude as well, like a magic function.
just for lols.
Like unsafe perform IO. You convert a bool to an integer. That's useful.
Yeah, but that's not dangerous.
No, yeah, I know. Just because we have true types, but
I mean, something dangerous would be, oh, okay, you are defining the type of the. Oh, okay, oh, that's evil. Yeah, an expression that literally is get this expression and assigns the result of it in the context to any arbitrary type. So it would be a set type in the context at the user level. That would be evil, man.
evil. I like the term evil.
Yeah, because you could do like intentionally, like could do. Oh man. And it's basically the same as the thing we do with magic and box and shit. It's just more imperative, I
The
guess.
unboxes just said. Okay.
Ooh, I'm gonna have to remove the variadic from here. So we're not gonna have circular dependencies.
What?
Yeah, because right
Mhm.
now the the
Okay, you
type
can call
type
type
is
that
there.
has a variadic inside. Yeah.
Yeah, and the variadic is in the basic, but
Oh, but that's not a problem.
well, what do you talk? Wait, what?
Because if you can have variadic, that means it's another function. Wait, variadic cannot have a type cannot be variadic, right?
Yeah, a type doesn't have variadic inside.
Yeah, it's just an abstraction. So
Hmm? Abstraction?
yeah, just like the arguments of an abstraction.
Oh, okay.
I don't think that's a circular.
No,
That
it is a
doesn't sound
circular
like a
it is a
problem.
circular dependency because it is using the type parser, which is defined in a knife, but
Mhm.
the variadic is being used like this file is being
You're
imported
thinking
by
too much
knife.
already. Just ignore it.
Yeah, okay.
You're thinking too much. Don't think.
This new philosophy of not of Mageta,
Yeah,
man.
man. I was infected by Rob Pike.
Oh, okay. Because you. Oh, I see. Because you have the basic that's supposed to be a library,
Yeah,
right?
yeah, yeah,
But
yeah.
why do you have variadic there then?
Because it was 5 a.m. and
Oh.
I was not thinking correctly, probably.
Oh, I see. I see. That's what you meant.
Okay.
The language is you gotta think that the language is like dynamic as well, so it would just load stuff when it needs to. It's like
Hmm.
it's like
Uh,
laziness, man, but worse.
yeah, that's the thing that I was about to say. Like, what about Haskell? Can you do SQL dependencies like without problems in
Yes,
Haskell?
you can.
Yeah, that sounds shitty.
It's very hard to do though. Really don't. It's really a hassle. We don't recommend doing that.
To do it or to do it to work it?
To do it to work, to make it work.
Oh, okay.
Like it will complain about circular dependencies in any other language. The difference is that you have a way of getting around that warning.
Oh, okay, then it's a
It
same
will work.
decision.
It will work, but it will be very like man annoying to set it up. I think this is done. What do you guys think?
That looks
No
alright.
idea.
That looks alright. Just because I don't want to think, but that looks alright.
Just because I don't want to think, but it looks alright.
I mean, this app's so misleading, man. This thing.
It's applicative, man.
But I
Yeah,
know.
it could be application, right?
Yeah, but it's not. It's just applicative.
That's such a bad argument.
Do you have Unicode? You could use a rabbit emoji or something.
Oh, you probably can do those things in this, man.
Okay, now it
Like,
seems correct, right? So the app will get the identifier and the type for me, which will put that in applicative, which is what I want.
Yeah.
It is a just left because it's ignoring all of these other things, and it's just right because it's ignoring the beginning. Yeah, so I
Dude,
think this is right.
You know what I think is funny? We're probably one of the only people in this planet that actually have a monetic parser combinator library for LFA.
Yeah,
oh,
that's.
okay, yeah. When you said for LFA, oh, yeah, then that's true. Before that, I was not sold on the idea.
Anyway, keep going. I just wanted to note that.
Wait. What is the difference between char and prefix, man?
Char,
Char is only one.
yeah,
Prefix is like a
prefix
set
is a
of.
set of
I think
multiple.
it uses like multiple
Yeah,
chars. I
this
think
is
it's
using any
many.
char.
But it could be literally be the same, right?
Yeah, you can.
Yeah, with many, yes.
No. I mean, in our case, where
No, we
char
cannot. You
is.
cannot. You cannot do. You cannot swap them here because the implementation of char
Oh,
is
okay,
using
so
any char, and
Is
because
using
in any char is assuming it is only one, I guess.
uh
yeah,
okay,
but
but
it also has
if you
like
did prefix there with only one, it would work, right?
Oh yeah,
yeah.
it would.
Okay.
Wait, do I have the thing already here? Yeah, I do. Oh, and this is wrong.
Important.
Yeah.
Invariant character. Which one? Nobody knows.
Countered.
That's a really good question.
Let's do the following. Let's do
Product.
parameters and remove this.
Kill me.
Do you know why it's not working, Nathan? It's because Maget is not singing Halo, man. That's why.
Well, that would give us more chance for sure.
Didn't find a specific character char now.
Okay, that's advantage of monadic parsers. Well, parsers combinator. Like, since it's like you can compose stuff, you can also test on a piece, right?
Yeah.
That helps a lot.
Try to run only on very yeah. I like more Oblivion's music.
That's actually really good music, man.
Didn't find specific char.
So,
Where are you using this error,
Oh,
man?
I know. I know.
oh, it's in the opposite order, right?
Yeah.
The E is inside.
Uh, just
Yeah, just swap. No.
Swapping will not work.
Yeah,
wait,
it
but
uses the white spaces.
isn't identifier what we want?
You gotta remove the white spaces, right? This
Oh,
case.
okay.
Yeah, I gotta remove the white spaces. Ignore that. And go. Oh, okay, wait. I think this is wrong again. We need to add an applicate. No, just left to this one. And we need this pink one.
Yeah, inside makes sense.
We're still lacking a parenthesis in somewhere.
In the end, I think you just dropped one off.
Just
Yeah, just
left. Ooh, just left undefined.
Just left one. Was it one? What was the arity? Just left. Wait. Which function? App?
App.
Oh, yeah, there's only one thing.
Where?
There. It's only one. They're just right. It's the only
Oh.
thing inside app.
Oh, so the parenthesis is wrong here.
There, it ends on the just left.
It
Wait. No.
ends.
It ends on the just left. There.
Oh, here. Is that correct now?
Yeah.
No, no, it's not. It's.
Well, no. Yeah, I should have one there instead for the applicative.
Oh no, the
Yeah.
applicative. No, the applicative needs to pick the both just right and just left. So it's just right identifier, which is correct,
Yes.
and just left, ignoring. Yeah, I think now it's correct. Let's
What?
see.
No, then that's wrong.
I'm confused then.
Like, the applicative should end on the just left.
The applicative should end in this one, you say.
Yeah, because you pick the identifier plus the type. And that goes outside in the just left. No, I'm talking about the inner just left. This one.
The inner just left. You mean this
Just
one?
add the new parentheses in the end of the type. Yeah,
Add new parenthesis
this.
at the end of the type.
Add another one. There. And
No,
then you
this is
remove
wrong.
one. And then you remove from the end. That's what I see.
Oh, you were thinking about parsing in a different way then. I was thinking about using just left to pick the
Hmm.
just right and ignore this. But you are thinking about using this just left to
Oh,
ignore
right.
this.
I didn't see it just right inside the thing.
Yeah, but now
Uh,
we can,
yeah,
using
then.
your way, we can just do
Yeah, I can remove that. Yeah. Another one.
this.
Remove another one on the beginning. Yeah.
Oh, you were using the white spaces inside the application, but just to discard it?
Yeah,
Okay.
we're gonna discard the white spaces in the char.
Oh
And then
yeah,
it's
looks more
close there, I
plain.
guess.
This is looking right now.
No, it's not.
It's not missing
You
token now.
close. You
Oh,
close another one there. No, 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 not there. There.
makes sense.
Yeah.
Makes sense. Okay. Ah,
Damn.
nice. Okay. Um, here you guys want to go straight up for gold?
Yeah, dude. Don't lose time
Oh
on
fuck,
function.
still hurts.
Full speed. Forgot the music from Sonic, but anyway,
Music from Soul.
Sonic Adventure.
Nope.
Quack, 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 quack.
Is
Bad
this written? Is
argument.
this written right?
Wait, was that
Um,
really error with your string? What is that error, man?
I
Bad argument?
bad argument. Error
Exception
plus
error.
plus argument.
Yeah, that sounds like a LFA error.
No,
On
but
and append.
do you guys see any problems with this abstraction? This is an abstraction,
No,
right?
this looks fine. Yeah.
Along with the brackets, and then you have the parameters with the types.
Yeah, it looks fine.
Then you have the variadic part being done here. Okay, so we shouldn't have. we, let's just try the baby steps. Maybe the parameters are the wrong ones.
I think that's the thing. That's what?
Huh.
That's bad. So
What the?
so it is correct indeed. Um,
It tried to append
oh,
something. Like,
oh, wait, it's this guy. This guy is now wrong. Huh.
oh
Make
yeah,
a
that's
mistake.
true.
Uh,
Oh.
so the list of parameters, now they are like this.
Mm-hmm. Yeah, that's Vero.
Okay, so the parameters, they will need now a mapping for them specifically to transform to the atom,
Mm-hmm.
and the variadic body will also require that. Are we type checking the variadic part in the compiler?
Yes.
I don't remember any of that.
We check if all the elements are the same type as the boolean because we don't have a list. If we
And
do,
other stuff.
Interesting, I didn't know that.
You literally did it.
yeah, man.
Like you did the thing right.
Okay, so the parameters they we can just pattern match them. Cool. So we're gonna do
Although I hate this.
you hate it.
This notation is horrible.
Arg
I need another, right?
type.
Like, don't you need another parenthesis before the tuple?
I don't think so.
That's what you're doing on the make abstraction.
Oh yeah,
Yeah,
that's
because
correct.
it's a
That's
function
yeah, it is.
declaration.
It is. Yeah, that's exactly
That's
right.
cringe.
Wait, pattern mesh?
And yeah, this is
Oh,
pattern
but
matching to
yeah.
unwrap, and then we need to do a tuple with the. Ooh, that sucks, but we're gonna have to do it that way.
But wait, you close one there. No, no, close
Uh,
like after the integer.
just a sec. Let's just me finish this because I am uh, thinking. Arg. Okay, go.
You close one parenthesis after the integer.
You close one parenthesis after the integer.
No, yeah, that. And then you remove one. Yeah,
Is this correct?
yeah, looks like it.
It looks like it. Yeah, this looks like it, yeah. So then we need to pick this again. Boolean.
Actually, I don't know. Do we only have a tuple? Mm, I don't.
I think we're doing like
Well,
this, though.
maybe that's. I think that's
Oh, we
right.
have tests.
Wait a
Wait.
second.
That's
Yeah, we have tests for type checking. I forgot. Nope. No. Wrong project. Test. Typer. Do we have for abstraction? Yeah, we do. Ooh, but this is using a slightly different notation, right? Oh, it's because oh man, we need to change this eventually. Yeah, yeah. The ESTs from the evaluator and the type checker, they're
oh
completely
yeah, your
different.
tests
They are
will
completely different. Yeah, we need to change both of them, but that's for
go
Friday.
false. Test, you
This
mean?
screen is blinding me.
Yeah, to put like argument, and then here we put the another tuple, I don't know, with the type and the name.
Yeah, it is with the type. Yeah, I just checked.
No, it is like this,
Go
right?
on the typer.
It is like this. But the
Yeah,
problem is
with
that this is wrong, right? Because this is like type and the name, but we want to use the same EST for the evaluator and the type checker, so we need to adapt these both of them. Both of them are wrong. This is excluding the argument in here.
well, the
And the
evaluator AST is wrong, right?
no, this is also wrong. Because
What? No.
yeah, let me explain. So look at the abstraction. We have the variadic info here, which is fine.
Yeah.
But look at the list. The list here is a list of tuples in which we have the type and the name. In the evaluator, the abstraction has also a list, but the list has an atom argument.
Yeah,
So,
on the evaluator it's wrong.
wait.
Like you don't need that argument there.
Oh, that's correct. This is always an argument. We don't have to
Yeah.
specify that. Okay, makes sense. That makes sense. Got it. So we don't need the extra crap.
It's the crap.
Yeah.
Look at the way he speaks with the language. I need to close. Yeah.
Well, that sounds precise.
The sarcasm here is like at max level,
Okay,
man.
we also need to check the variadic part. Okay, so we have the rest. Oh, no, not here. Type. Do we have a type checking procedure for the
Yeah,
rest?
trust the typer, the type checking thing, because this we did
We don't
later.
have one. Oh, no,
Wait,
we do,
we
we
don't
do, we
have.
do. Okay, nice. So we just return the type and the rest. Okay, type and rest. Where is that? Make rest. Make rest. Same thing. Grab this.
But wait, go back there, Lemus.
Where?
Are we specifically naming REST on the
Yeah.
browser? No,
Yeah.
but that's the name of the thing, not the atom, is it?
Oh, that's correct. We in
That's
the
a name. That's a variable, I guess. Go back
yeah.
there.
Where? Here?
Let's see. Uh oh, that's just like integer rest.
Yeah.
Okay, because the rest is the name. Yeah, that's right. The rest is the name.
The rest is the name. Yeah.
We're handling the last one as necessarily variadic. That's why.
Uh. Okay.
So it's like
So
it goes together with the other arguments, but it's just the last. The what matters is the flag in the front.
yeah. But I am. Oh, here. So the name and the type. Okay. So str and type. Let me do
Capital
this.
letter. Oh no, no. Sorry, that's not our link.
Uh. Wait. Is that it then? Oh, it's in reverse order. Type.
Yeah.
Uh. str. But I don't like that because yeah, we're gonna have to make an auxiliary function to map these things. It's a real pain in the butt replicating the same stuff. So let's make that. Define string to type. Then oh, I think we need the second one, right? I get that?
What I'm looking. Let me see. We need the second one.
Yeah, the
Which
second
one?
parent is the blue ones.
Uh, I thought you needed on the integer instead.
Really?
Yes, not on the second.
Not on the second, really?
Yes. Because they are arguments for the thing, and this is the
I'm
response.
pretty sure we don't, but let's try.
Wait, are you going to return like new if it doesn't match, and then you will check on new on the parser to return a failed parser?
No, I will not do like that.
How are you doing that? Because the mapping can fail, so the parser can do the same.
Wait a sec. The thing can fail.
By the way, I just remember we forgot to add a null.
We don't have a null, man.
Why not?
Because no nulls.
Come on, man. Don't you want to move fast?
I think
Null
that
allows the
we.
programmer to move fast.
I don't think it. Wait, can we add a new? I
Uninterpreted? I
think we
don't think it
can.
makes
It's like.
sense.
No, well, technically you can, but I mean, if
Yeah,
you
it
don't
doesn't
have
mean
like a complex object, right? You don't have.
Oh man.
but I'm just joking, man. No, don't even think of adding that.
Okay, I know the solution for this, but that's gonna require a little bit more time.
But
So
I mean, Magita, do we have some operation that is like not total, not total, I guess.
Yeah,
Do we have
total.
something that can fail?
for now, I'm gonna replicate, but I have the solution for that. I'm gonna use parse bind to
I'm
fix.
thinking.
We don't even have division, right?
Yeah, we don't.
Yeah,
No,
we
we do
can
have
have.
division. We do, but it's
Oh
like
yeah, the result could be null.
yeah. Nice.
Man, like, you really don't think it's a better idea to use the the prefix and empty with the thing as mapping? Because then you don't need all of those weird stuff, man.
What is the weird stuff?
That weird mapping. It's a mapping that can fail. Then you need a
No,
count
no,
for the
no.
failure
This is
and
not.
check.
This is not the long-term solution.
What is the
The long-term solution
long-term
is using
solution?
parser bind.
Parser binds.
But I will not. It's the same way that I removed the lambda from being a valid name. But I will not do this right now because it's going to take some time. But the problem that we have is that how we make an empty tuple.
Yeah.
How do you
I
pattern match
empty
an empty
tab.
tuple, Mageta?
Wait, what do you want to do?
Pattern match an empty tuple.
I think you can just match tuple.
You mean like this?
No, yeah, like that.
Wait, where are you creating an empty tuple?
Yeah, but what does it mean to be an empty tuple?
It
Don't
means
you
that
want to return new?
Yeah, like isn't it an empty list instead?
no. It is an empty tuple. Imagine this but empty.
You don't have types, Lemus. You can return an empty list instead.
No. We have to pattern match it somehow. That's my point.
Wow, the new we know how to do.
Okay, so we don't know how to pattern match an empty tuple.
I'll try. I think that's it. That's how.
Is that even valid?
That's a good question.
Okay, so the parser bind.
The parser bind is able to.
I
It
could
will.
try here, but
Symbol str is unbound. Where is str? Oh. No, wait, what? Confused? str boolean. Oh, I know why. Oh, we can just reuse. We don't need make
Is it
rest.
you pass a function to a parser, and if the parser succeeds, he does a mapping that will return a result?
Yeah.
Okay. Let me see.
Okay, it worked this time. But I think it was already working, no?
this time.
Oh, but we need to change it.
Let me ask Magita. Magita, what do you think about this kind of expression as to do a quote unquote mapping?
Let me see. Return some operator.
Yeah, this is a mapping.
Yeah.
No, but that's not the one that you said when I told you something and you confirmed. You're not passing like a
Yes, it is.
function that you returned it. No.
Yeah,
No,
it
that's
is.
not anything.
We use parser bind.
No, return some operator. It's like a parser, right? What I described to you, I'm not sure.
No, it
No,
Okay,
is.
no.
It is a
depends.
monadic function that you're passing, Nathan.
Yeah.
No. The description that I gave to you and you
Okay,
confirm
maybe I
was
didn't get it right away then.
okay. But yeah, I think it could be a parser because I said you receive something only if the first one like succeeded, of course, is the binding, and then you do a mapping that will return a result, right? But
Yeah, it
that's
is.
not necessarily a parser.
Yeah, but the way that I'm gonna do it is using because the thing that you, for instance, look at this variable here.
Okay.
I wanted to make the identifier deny lambda as a possible variable.
Deny lambda as a possible value. Okay.
So I binded a function, a parser, a monadic function in this case, which is this guy, that will like it's exactly what you have written
Yeah,
there.
but you could leverage something else to do that. You could literally do alternative first that match the name lambda and then always fail.
Um,
Yeah.
yeah, but how I will make that interact with the identifier parser?
Well, you are in an alternative, so you are getting the input. If the input matches the lambda, then well, it will not go to the identifier one. If it passes, then it's a valid identifier, right?
Oh, you would compose the prefix one with the fail one.
Yeah, like
Oh,
if it
okay, okay,
matches, then
okay, that works. Yeah, that's essentially what the parser bind is doing. So,
yeah, sure.
okay, so what I was doing, I forgot. Oh, I was making a thing here. Okay. Okay, this is an
Sometimes too.
abstraction, right?
Yeah.
Okay.
Oh, 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 oh.
No, it's not working at all. Nice. Uh, okay. Let's do the
Where is it
following.
failing? It's failing on the append of integer x and integer y.
Append.
Yeah, that's like plus plus right there, right?
Yeah, but it's saying here list append. Where am I
Oh yeah.
doing append?
Good
Am I doing
question.
append here? Oh yeah, I am.
Ah. So
Uh,
you're
t- t-
making
t-
an
t- t-
argument, which is that crap. This is just sad.
This is just sad.
Magita, look what I just will send you on private, man. Like I
Okay.
literally just saw that on Twitter. Twitter.
Uh, apparently, this is not how you pattern match an empty tuple, man.
Use an empty list, man. Like
Um,
empty tuple, maybe it's not even a thing.
Oh no, we don't have the option of changing this to a list at this point.
that's totally
Why?
ludicrous.
Because that would require a change in the applicative parser.
How?
Because the applicative is always throwing a tuple. And we would have to change every single other function.
Can you show me where are you returning an empty tuple from the applicative?
Dude, man, let me
Because you
try
don't
to.
have types, Lemos. You can return sometimes a tuple, sometimes a new. Like
Sometimes something, sometimes
Yeah,
not.
but
Sometimes a
that
whole nother.
would make
you
the
not knowing
applicative
is the fun,
parser
right, Magita?
that would make the
Sometimes.
applicative parser terrible, right? Or am I going crazy?
Are you sure that
Oh
you
man.
need to change that on the applicative parser?
Yes.
Isn't an arbitrary
No.
return that he sends
No.
to you,
No.
depending on the function that you
No.
applied on the?
No. The applicative
Mm,
always
can
returns a
you show
tuple.
me then?
Uh,
In which case it is returning an empty tuple?
yes, that I can show you. Is the optional.
The optional.
Wait, the optional we can change.
Like if you say to me that you are returning that, then I can say to you that you can probably match that.
What is the empty returning? Oh, it is an empty list indeed. I am stuck in crap. Okay. Okay, so just this.
Yeah.
This
Yeah, I
situation is
think
fine.
that will handle as an empty list. It should.
Nope. It
Let
is
me see.
breaking.
Try just list, like just a keyword list inside the thing. Yeah.
I doubt it. Yep. Integer, integer.
I I don't know.
Wait, what is the problem?
Just a sec.
Isn't the same literal as the empty list as you did to return?
No, that's not the problem. We are already tired, man.
Remove the list.
No, no, no.
Wait, do you want to
No,
match?
wait.
Remove
Yeah.
the
Listen,
no no
listen,
no.
listen. It is not executing this line, which means that it's pattern matching correctly. You know why? Because the problem with append, the only way of
Yeah.
appending if it you
This,
skip this.
you bypass this, yes.
So
Remove the quote.
where?
Oh, but this function is variadic, right?
Yeah.
Okay.
So we are grabbing, we are making.
But is it variadic because do the following then. Move the variadic first. No, never mind. Mm-hmm. That's very garbage, but yeah. I'm not in a position to complain anymore. I'm in a pragmatic position now.
What? This is correct, right? Am I crazy?
Oh
This is correct. This needs to be correct.
no, this is
And
wrong.
needs to be correct.
No, this is wrong, isn't it? Let me
No,
see. What are you printing? I didn't see.
here.
What? No, no. What are you printing?
I'm printing the list of arguments in the variadic part.
Wait, what are those brackets? Did you change that?
No, this
No,
bracket
it's
just
just a
because it's a
tuple.
list.
Yeah, list and a tuple.
Yes.
Yeah, it's a list of tuples. List of tuples.
No,
And
the curly braces, like
Tuple.
curly brackets.
no, the curly braces is because it's of tuple, right?
Yeah,
Oh,
because the
it's two
function is
arguments to
Erlang.
parse?
Because it's an Erlang function.
Man,
So
Nathan Stein.
No, no. Like, I mean, doesn't parse only receive a string?
parse.
uh,
Wait. Aren't those arguments to parse? Like
no, man.
the
Man,
Those
we
were
are transforming the
yes.
parsed result from the parser to the
Lemons,
notation that the compiler is using.
the LFA there. You are invoking this function. Oh
That's
shit,
not an FA. That's Erlang, by the way.
that's their lang. You literally have like LFA there.
No.
The
What?
name
Where?
there, like before the angle brackets.
Yeah, no, this is LFA, but we are calling an Erlang function.
The print is handling that as a like it's showing like that because it's an Erlang function.
Yeah.
So the formats are like that.
Okay. Sorry, that was the output, right? Not the
Yeah.
input. I see.
Yeah.
How is this appending not working? What
I
the?
don't know.
Appending. Oh, I need a little bit more of brightness because I can't see your parentheses, right?
Oh yeah, it's because it's a very very dark blue one.
Oh, and
That's
also
good.
I'm in like reading mode.
Append. My append is breaking. Why?
So append takes
Oh no, my append should break in this case. That's correct. Because I'm not providing the second argument there.
okay.
Okay, this is correct.
Bad
We
argument.
have the type and the name, which is fine.
What we're
Now,
trying to append a lists map with the make argument and the argument the variadic part.
yeah. I wanted to
Can
do
you
use an
print
insert, but we don't have insert in here.
print each one of those expressions? Maybe they're different.
Just a sec.
Wait, if you saw that the append is working because we are only applying one,
What the crap?
why don't we fix that?
Because
No, but
we cannot append only one.
Well, you can append on an empty list,
yeah,
but why are we using append if we don't want to append these things?
Because we want to append them.
yeah, we
What?
want to
In what?
flatten them all.
We want to append the list of arguments which are not variadic with the variadic part.
Oh.
Yeah, that's how our AST
Okay,
is.
can you show me where are those in that function make abstraction? I see parameters there. That's a list, right?
This is the non-variadic, and this is a list,
Okay.
and this is the variadic.
Also a list.
No,
Yeah, so, no,
tuple,
No.
yeah, no.
tuple.
This is a only element, and the parameters is a list. Do the
Wait,
Yeah.
following
why don't you
exercise.
cons?
Yes, that's what I was going to say. But do it like this first. Do a lists map and print that thing in the f right.
Where map what to what? This you mean?
List map. Yes,
I
this,
already printed this
and it was mapping correctly.
here.
Okay. And what about the variadic? The same,
The
right?
variadic is this, but this is wrong, right? Because this
Yeah,
is
but you're wrapping a list before.
oh, it needs two lists wrapping.
No, but it's already wrapping a list.
Yeah, it needs to be like
What?
this.
Oh yeah.
Are we accounting for the rest to be the last one?
Yes.
Yes.
Yeah, then you need to wrap in a list and append, right? As the right one.
Yes,
Try to do a cons
which is this.
instead.
No, you can do a cons if you are counting it to be the last.
No, you can. You just swap the order.
You just swap the order. Fair.
Okay, the cons I already forgot. The cons is adding at the beginning or at the end?
Oh no, this actually has problems. You can't just change arbitrarily the order of the order
Oh,
arguments.
never mind, because the cons, the head needs to be an atom, like a
That's not a
normal
problem.
element.
The variadic is that. The problem is when you reverse, you
No,
change the order of
Oh,
the
the
other
cons is in
of
the
all the
parameters.
beginning. Yeah.
arguments. Yes, that's problem.
The changing the order, it will make a wrong error to the user during the type checking.
So yeah, it
Let's.
should be list append. And this was working before.
Yeah, like see the variadic, put the variadic inside the list and pass as
Oh,
the second argument.
No.
yeah. No, that's wrong. Yes, that's right.
Is it the
Isn't
parenthesis the
lacking?
problem? That's the
Yeah, the
way.
parenthesis is lacking one. Yeah,
No, but
but
it
I don't
was
think
that the
that's
problem
it.
from the beginning?
No, yeah, I don't think it is. Oh, you gotta be joking me. What the
It
heck?
Oh
is.
fuck, parentheses.
It is.
No, man, that's terrible because like in a normal Lisp, it would show the parentheses that's wrong.
Yeah.
No, but like you were with valid parentheses in the sense of was not unbalanced, but they were in the
No,
wrong place. Like you were applying
it's
only
not an
one thing to
unbalanced.
append, right?
Okay, yes, on the compiler it shows that's true.
Oh. Okay.
What is
Yeah.
make argument, by the way?
This.
Oh, okay, just you transforming to the right part of the ST, right?
That's why I had an extra parenthesis right there. Okay.
Yeah,
Mageta, would you really be willing to work with a language like that?
no,
Why?
Wait, we're talking about what?
LFA.
Oh.
no.
Okay, what about I don't know, closure?
Yeah, okay.
What is the part of LFA that you
Uh, no documentation at all. It has a
Oh, wait,
footnote.
you can't say at all.
No, dude, it has like compared that
The
to
a
closure or
good user
combinator, it
guide.
has nothing.
It has
Tooling is
a
horrible.
single user guide in a text file in a
Is a
GitHub.
it is a huge user guide. Like it's not a line or
Tooling,
two.
tooling is horrible.
It has
Libraries,
all their Lang ecosystem. What you're talking about?
yeah, which is not good.
Oh, come on, man.
Okay, now we are talking, boys. It's correct. Okay, we know how to parse. Oh no, we need to also do more extraordinary examples in this case. So file. Uh, oh, I removed when we were doing the library stuff. Okay, so file content, expression. Remove this. File content. Okay, let's make here. So give me a good example, guys.
Um,
Um,
did we
you
test with
have one right there.
No, we didn't test with the arrow, right?
Yes.
The mapping will
Oh
break.
shit!
The mapping will break.
Oh man, I'm really not trusting that arrow parser, man. Like I don't know. I
Or
You're
don't
we
know.
not
just
trusting
simply
my
do not
parser
add.
now.
Yeah, I don't know. I don't know.
You're not trusting my parser now.
That
How dare
arrow
you?
one.
That looks
Mm,
sketchy. No, man.
looks sketch. Oh fuck, man. Make arrow. Oh wait, it's not even finished. Oh.
Uh,
By the way, I think that's such a weird idea, Lemus.
what?
Like maybe with types you would realize that, but your parser doesn't return the piece of the ST.
No, it's because.
You have to
But
do
I
something
told. Yeah,
else
but I
after.
told you this last time. The types are the
Hmm,
interface between the parser and the compiler, but we don't have them.
okay.
So
Yeah, that doesn't mean that you shouldn't like put outside the transformation into the EST.
no, but we're not putting outside. We're gonna map it.
Will your parse error return a part of the ST?
It will return the node, yes.
Okay.
Where is that? Oh, here. Uh, okay, so we want to make these to be similar. The first thing is ignoring what we ignore in the parser, which is all of this.
Yeah, what is variadic info?
It is the
The
information if the function is
But
very.
I mean, what's the format, right? Can't you paste there also?
Wait just a sec.
damn. Oh, bro.
Is
You
Because
this
want
that,
to see
impossible?
the well,
yes,
of course
I
it's
think so.
possible, man.
No, no. It is probably it is possible if you have some scratch, but is our parser capable of doing stuff like that?
What do you
Actually,
mean? Like, if we have the applicative, we can do anything, don't we? I mean,
no, no, no,
mapping,
no.
for
The problem is
instance.
not that. The problem is finding if the thing is variadic or not in the arrow. Is that
We
No,
it?
no,
can't. We can't.
no, wait.
Oh no, but we can pattern
It's
match here and add it
optional,
and edit it
right?
later. That's
Oh
fine.
yeah, that's true.
Okay, so we're gonna ignore the variadic info for now. Okay, so we have the type. Then we have another type.
Wait,
Yeah,
isn't the question like if you can like the parser return something that you can say if the info is variadic or not? Isn't that just the optional thing? The optional with
Yeah,
some
yeah, no,
payload,
yeah,
then you
no,
match the
yeah,
payload.
but it's what Mageta and I said. So you, for now, because using only the arrow, you're not able to say that.
You are not able to say
Yeah,
that.
only when you have an abstraction are you able to say if it is variadic or not. So what's gonna
Oh
happen is the
yeah, yeah,
following:
of course.
we're gonna have to do another pattern match in the make abstraction specifically for whatever is the output of this that we're gonna make it right now.
let's clap for a moment for this beauty of engineering.
Mm.
Yeah, but let's finish the recording for today. I think it's long enough. Almost 3